computer. Perfect. Now we're recording. Ask your question.
I'm still a bit confused about over there when you did the lower boundaries. So the upper boundaries, the easy way to remember is just the number before the next digit.
Which is the next lower boundary.
Yeah. But then lower boundary is an easy way to remember. What's the easy way to remember?
Like where the range starts.
Yeah, anything else.
Okay, I'm thinking. Give me a second. Well, the gun range. Fire one bullet. There's your one. That's your lower limit. Or you fire 99 of them. That's your upper limit. Your interval would be you and Andy go to the gun range and you shoot 10 bullets, and then you go get like a soda and then you shoot 10 more. Those are your intervals, like your interval width. Your interval width would be from 1 to 10. That'd be your first one. Then you guys come back and you shoot from 11 to 20. That's your next interval. That's your range.
What's the lower?
So your lower boundary would be 1, 11, 21. Your upper boundary would be 10, 20, 30, 40. I'm saying assuming you guys shoot 10 bullets at the gun range.
Okay, so upper is the number.
Like where you take the break and where you stop.
Before the next
Interval.
digit, the next number, and then the lower boundary is the one before the first one.
The lower boundary is like your starting point for your intervals. So let's.
So like, see, the lower boundary in this interval is 1. So like the lower boundary here is 11, and then upper is 20.
Hey, Janessa.
See how these are all split?
Glad you're here.
And the width of these,
Okay, cool.
like,
Lower boundary is just this number.
yep, the lower boundary is the lower number at the start. Yeah.
Okay, perfect. Hi. So we're talking about lower boundaries and upper boundaries and how we get there. I have the math on the board. So basically I was explaining to Daifa, like you can think of lower boundaries and like the range, like going to the gun range. So you go to the gun range, you shoot 1 bullet, that's your lower boundary.
Okay.
You and a friend go, you shoot 10 bullets and you take a break, get a soda, then you go back. So your upper boundary would be 10. And then the next time you're firing the gun, 11 to 20, upper lower boundaries. Like we're talking about that. We're talking about how to get there. So if you get the random question that's been coming up on WebAssign that's been wonky is it says, give me the interval width. And it gives you 2 numbers. And you're like, well, how the hell do I get the interval width? Well, what you do is you take the 2 numbers and you subtract one from the other. That's your range. But you need your real range. So you have to add 1 because it's 0.5 on the left, on the very bottom, and 0.5 above. So you add 1. So your real range is divided by the number of intervals. They only give you 1 interval. So it's just the difference in the numbers plus 1 divided by 1 because you only have 1 interval. That's your interval width. That's how you get that number. So like if they say 25 to 37, this would be what, like, is that right? 12? Is that 13?
These are different intervals.
Oh, yeah, it's 12. 12, that's my range. My real range would be 13. And then I plug that back in here, 13 divided by the number of intervals, 1. So my interval width is 13.
Hang on. So I got the 12 plus 1 equals 13, which is the real range. And then what did you do after that?
So I have,
You did 13 and then you did what?
can you see that?
Yeah.
Okay, so interval
Okay.
width is always equal to the real range over the number of intervals. And the range is always, the range is the difference in numbers, and the real range is the difference in numbers plus 1.
Plus 1. Okay.
The range is equal to the Like, for example, if we said 37 minus 25, that would be 12, right?
Right.
Then if we want the real range is always the range plus 1.
Yeah.
So that would be 12 plus 1 is 13. Now, where do we get that from? We're taking 37.5 on the upper boundary and 24.5 on the lower boundary. It's 0.5 above and below the two higher and lower numbers. That's where that comes from. So the interval width, real range is 13. So we plugged it in right here,
Mm-hmm.
and they only gave you one interval. Anything divided by 1 is the same number. So that would be 13.
Gotcha.
That's how you get that. That's been the one that's coming up on WebAssign. Ariel, yeah.
Okay, so sorry for some question, but, so I wanna go back to like this upper lower thing. If
Yeah.
I wanted to do like an interval of like find the interval width between 22 and 87, would it be like 87 minus 22 plus 1 divided by 1? 7? Because that's how many intervals.
Because it'd be the number of intervals, yeah.
And that's how you would find the interval width. Is that correct? Like if you took 87 minus 22. Oh wait, sorry, hold on. 1, 2, 3, 4, 5. It would be divided by 6. So it would be like 87 minus 22, which is.
Yeah, but in this case, you'd be talking about the real range from start to finish for that math to work.
Okay,
That's why, because you have more intervals.
okay,
So this would not be what you said. It would be like your 109 minus your 1
okay,
plus 1 to get to the real range, and then divided by 7, and the math would work. The
okay,
reason it works over here is because they're only giving you one interval.
okay. Oh, okay.
We have multiple intervals, so we have to account for the entire range. The entire range is bigger because there's several intervals.
Okay. So back to this.
Yes.
Example, how many intervals are there?
So this example, you're going to bring you, what, you over here with me?
4?
Yeah, you're fine.
Okay,
I'm watching.
okay. So over here, so we did upper boundaries, right? So we had 22, 44, 66, 88, and then we were like, what are the lower boundaries? Well, 43 comes before 44. So the first lower boundary is 43.
Do we count the 1 or no?
The 1 counts as lower boundary too. We just did that. I mean, you can remember that as 1, but we figured that out a different way. So we said 43, 65, 87. And then we found that the interval distance was, the difference between those was exactly 21.
Wait, you just said lower boundary from 22 to 44 is 43?
Yeah, because, no. These are lower boundaries on the bottom, and these are upper on the top. So, like, make more sense if we wrote it like this. Let's just actually like, what do we have? We have 44. We have 66. And we have 88. And that's it.
Started with 22.
Yeah.
Yeah, you started at 22.
And we started at 22.
2, 4.
And we said that these were upper boundaries,
These set of numbers are
or upper boundaries
for what set of numbers?
for the set of numbers. So we're saying what are the lower boundaries? Now we could typically assume the first one's always 1, but how do we get there? Well, if you got
Is this an old word? No, it's the same one.
the same one,
Right.
if you got 22 people and you're wanting to get, so you have 20 people, you're adding more people to your group. Maybe you're doing a bar crawl or something, you're adding more people to your group. Your next boundary or your cutoff where you're going to have your next group or interval of people, it can't be 44 because that's an upper. Yeah. So what is the lower boundary? 43. That's the lower boundary up. That's
The limit.
That's the limit,
because it can't overlap.
because it can't overlap. So this is gonna be 1, 43, 65, 87.
That's the lower boundary.
Those are,
Yeah.
yeah,
Think of it, the
Okay,
number
but
below.
2 seconds ago, you said upper boundary is the number before the, like, for example, 10, 20, 30, 40, 50.
so it depends on what we're saying for the, so we have an interval, width. So just think of this like interval width, and this can be any numbers, okay? So the one that starts here is your lower boundary. That's your lower boundary, and let's just say we start with 1. Well, if our upper boundary is, so that's our interval width, and we have numbers. So those were upper, right?
Yeah, the upper.
Yeah, so the upper, so 1 to 22, that's 1. And then the next one that we see is 44, right? And that's an upper boundary. So 23 in this next interval width is that lower boundary, okay? Like if we say, I think it makes more sense if we start with lower boundaries. I think it kind of like makes it make more sense. So we say the lower boundary is 1, lower boundary, 1, 22, 44, 66, and 88. Those are all lower boundaries. What are the upper boundaries? Upper. That's, I think, a much better way to think about it. Well, 21,
Isn't it right?
21,
40,
43,
43, 65, 87.
Because the whole time I thought you were saying.
But the problem is we have another number here because they're lower boundaries.
Hold on this one you put.
Did I write it? Did I write that backwards?
Yeah.
So lower boundary, where you, this lower boundary is where you start, upper boundary is where you end.
Okay.
Okay.
So I have to end here to get to the next lower boundary here.
Okay.
I have to end here to get to the next lower boundary here. I have to end this higher boundary here to get the next one here.
Okay, wait. So upper boundary is where you end -1.
That's, no.
You just said, upper boundary.
Upper boundary is, well, technically, yeah, it's the integer before. So this guy, he starts his lower boundary of 1. His next lower boundary is 22. So the upper boundary for that first one is 21. It's kind of like if we have a building and floors, and each one of the floors represents an interval, and you start on floor 1, and your next interval is floor 22. Well, you can't, to stay below floor 22, you have to get off on 21. If we're thinking about it like a building. So this would be a lower boundary. This would be an upper boundary. This would be your next lower boundary, next floor. Close to the ceiling would be 43.
So upper boundary is where you, upper boundary is where you end -1. Basically. Like that's a good way. Is that a
You
good way?
can think of it that way, but I would try to think of it like floors and ceilings. Because lower boundary is like that first floor. Upper boundary is like the ceiling before you get to the next floor of the interval.
That's upper boundary.
So which one is
Yeah.
the correct way? So the starting with lower and then upper, or starting with upper and lower, or does it not matter?
You could get there either way. You just got to think through it.
Oh,
So like 44. So this is like, 'cause you cannot break that barrier. So 44, and the next one was 66. So when we get really close to the ceiling, it's 65. It's below that boundary
That's the highest you can go.
before the next interval or the next set of
That's why it's called
floors.
upper.
Yeah. So like 66 and then 88. Well, then it's got to be 87 here. But if these are all lower boundaries, that means there's one more upper boundary past 88, right? Go ahead. You have a question?
So like if, like, I know that it's like, it can't be 22, but could it be 20? Or does it have to be one below, like
It has to be one below because the widths
Okay.
have to be the same
Okay,
for the intervals. And you can arbitrarily assign width, but you try to do it so that they're the same size.
The entire time I was under the assumption that like, for example, if like a question on a test would be like, here's a set of numbers, find the upper boundary and find the lower boundary.
Totally doable.
Okay, yeah. So, for example, 1 to 20, 20 to 40. The upper boundary for 1 to 20 is 19.
Yep,
Okay, and then the lower boundary is 1.
yep,
And then for 20 to 40, the lower boundary is 20,
yep.
and then the upper boundary is 39. It's 24.
Yeah, because the next set would start at 40, yeah.
So lower boundary is pretty much just the number you start with in every set.
And the number you start with up to before the one before the next lower boundary. I'm confusing the way I'm saying that. The lower boundary is where you start, the upper boundary is where you stop before you get to the next lower boundary.
Lower boundary is where you start.
Lower boundary is where you start, yeah.
Okay, so lower boundary and upper boundary are always one apart, always next to each other. Okay.
They're always right next to each other. Makes sense. See, it's clicking. Makes sense. Okay. All right, so I'm gonna go into chapter 3 and review unless you end up all having more questions. And yes, we will do our best to take a couple breaks, but not yet.
Chapter 3 was the ordinal and all that stuff, or was that chapter 2 or 1?
That was chapter 1. We're gonna go over through all of it right now. What I'm gonna do is I'm gonna finish chapter 3, and then I have lectures that are more granularity. And you can remind me, Janessa, make sure I'm screen sharing with you because you can see the slides too. Okay.
Oh, and can we also do an example of the interval width, that?
Oh, the formula.
Interval width, yeah, real
So
range
you
or-
got something on WebAssign that says something like. Give me if you have the two following numbers what is the interval width? Or it says something like, if you have an upper and lower boundary of these two numbers, what is it? So there's a question on the website that literally just gives you two numbers, says what's your interval width? So guys, give me some random two numbers. 12,
30.
30, perfect. What is the interval width? Well, the interval width,
18.
not quite. Interval width is always going to be equal to the real range over the number of intervals. Now, why is it 19? You're right. How do we get there?
Well, if it was like if there was another interval, I probably wouldn't have gotten that right, but I just knew the real range was 19.
So,
30 minus 12,
so 30 minus 12, that is the range. So that's 18.
and then
You add 1 to get the real range is 19, and then you plug it in here and you divide it by 1 because they only gave you one interval. That's how you know. That's
Two, like more than one interval.
Interval.
it's going to change it, but we could do that.
Interval is the width between two numbers, right?
Mhm. So this would be something. So the question, Andy, would probably be something like a list of lower or upper boundaries. And then you would just figure out basically like the floors I was showing you, like what point would it go up to? The first one's typically 1, but if they're gonna say like, what is your they're probably just something like this, where you have to figure it out, or they're gonna say, here's all the upper, here's all the lower, what are the other ones? And the way you know the number of intervals is the number of numbers. So for example, if we had something like the ones we just did, it was 22, 44, 66, 88. And those were all upper boundaries. So our lower boundaries were 1, 21, 43, 65, and 88. But there's going to be one more upper boundary, which would be 109. Why? Why? Because we know that the interval width is always 21. And how do we get that? Well, we took 22 minus 22 minus 1. But no, it would be actually that would be 110. It would be 110. So this is the real range, which is always the range plus 1. So 21 plus 1 is 22, divided by the number of intervals. And in this case, it'd be 1, 2, 3, 4, 5, but it'd be the whole range. Does that make sense? Or did I
So
totally?
you do 21 divided by 5.
22 divided by 5. Because the real range. Not 22.
And then that's
No. The real range between all the numbers, which would be between 1 and 110. So the real range would be
of all the numbers.
because it's the number of intervals. So if you only have one interval, it's very easy. But you have multiple interviews, you got to think of the whole range. You can't just do the interval range because you're not accounting for all of your intervals.
We do a harder example.
Always.
How do you get the 110?
We added 22, the real range, to 88.
So the highest number to the lowest.
No.
Or only
Well,
three?
we know that the real range is 22 between the numbers. So we added that.
88 first. So why 88? Why not?
Because we were trying to get the next number in the group,
Okay.
in the group, in terms of like the building and the ceiling, like
So you're
as we're going to the
trying
top floor, we're trying to figure out what the next one would be. So the upper and lower limits.
And then to find the interval width, we take like 110 minus 1 divided by
Be 110 minus 1 plus 1.
1 plus 1, so just do like
It'd just be 100. Is
111.
that right? No, it'd be 110, wouldn't it? 110 minus 1 is be 109 plus 1. So your range is the difference. Your real range can account for all the numbers. So it'd be 110 divided by however many intervals.
Okay.
Cool. All right. Free to keep asking questions.
Interval width formula.
Save. Statistics. Student resources. Where I got you, Janessa. Second. You're muted. I think you're muted.
Yes, I am. Sorry.
Hang on. No, that's not what I want. Okay. Student resources. Okay. Share. You see my screen?
Mm-hmm.
Okay. So I'm just going right here. In case, I mean, I'm sure they'll be fine. And I'm going to lecture A. I'm gonna go through lecture A through D, make sure we review.
Okay.
And that's right here. And then if you can't see PowerPoint, right? I need to reshare. I'm gonna
I can't-
reshare.
if you want, I can just split my screen and I can open up the PowerPoint,
Oh,
but that's up to you. Oh, I can see it too there.
actually,
Either or works.
that's not the one that I want. I want the other one.
Okay.
I want chapter 3 PowerPoint before A. Want me to screen share to show you what I'm looking at?
Hang on.
3 PowerPoint below the pretest. That's the one that I'm lecturing off of.
Okay. Hang on.
Chapter 3 PowerPoint. Yes. That's what we want.
Right underneath pretest, you said?
Yeah. It's
Okay.
kind of like that.
Perfect.
$14 an hour, guys.
What?
Federal work study. It's federally set.
And what do
What do you do?
If you're lucky, you get to study at work, but they can give you tasks and you work at the college.
You do what?
Like
They
what?
give you tasks. They give you stuff to do, but if you get all your tasks,
Tax. Look at a tax college student.
no, no puestos.
Wait, you do
No.
things like what? Like clean?
Like, so my favorite example, I went to UW Oshkosh, that's my alma mater. There was this guy that got put on the library and copier support. He literally sat at a desk and read his textbooks, and if the copier broke, he had to deal with it. That was a federal work study job.
Yeah, my friend, he handles the printer. Whenever somebody needs something printed, he just.
Yeah, he has to drop everything he's doing. He has to do whatever the thing is. But if it's slow, a lot of times you're allowed to study and get paid at school.
At whatever time?
It depends what you qualify for. It'd be through FAFSA.
Oh,
But if you qualify for federal work study, it's basically like the school pays you money, but you have to be careful on your hours because if you go over the hours you're allotted, the school has to pay the difference instead of the feds. But a lot of times it's generally a cake job that's really, really easy. We were using it with, we had some people, we were making them do a lot of stuff. We weren't allowing them to study because we had a lot of work that we needed help with.
I want to do this. Seems very easy.
Yeah. I think we left off on the mean. Chapter 3.
Oh, thank you.
The mean is an average. The formula is what you're looking at. The Greek mu divided by the sum of the amounts over n. Or the sample mean is equal to the sum of the values, that's the sigma, over n. N is the number of things that are in there. Like, pretty sure about that, maybe. Deck of cards, the N would be 52. Okay, that's the total number. Those will come back later. Okay. I'm going to prove later how cool math is. When we're on that chapter, yeah. We're not on that chapter yet.
Do you know any magic tricks? Do you know any magic tricks with cards?
It's a mathematical
Oh my
thing.
Hey,
Yeah.
Professor. What was, you said you called something a mean?
Greek mu, this right here. Greek mu, right here. That's how you write it. Or M for mean, if you're talking about the sample, the formula is essentially the same. The sum of all the values. What the hell does that mean? Kind of like this. The sum of the values over n, or the sum of the values over n. And this is the Greek mu, kind of like that, or it's the mean. But that means, what this actually means, if I go 5, 6, 95, 24, 36, 12, the sum of the values. So I add all these values together, I get the sum, and then I divide it by n, which is 1, 2, 3, 4, 5, 6. I got 6 of them. So it'd be the sum divided by 6, that will be your average.
So I'm kind of dense. What is the definition of the mean?
Average.
Thank you.
So let's look at that on Excel. Average.
No, I know. Just like I don't know why. Like it's always the Greeks. It's always the Greeks.
Always Greeks. They're just effing stuff up for us, right?
Always. Adding numbers and letters. And
Calling things mute.
Microsoft Excel.
Oh, I'm in Excel.
Because I'm going to show you what the average looks like.
Can we do
In
this
Excel.
SPSS?
Hell yeah, you can do it in SPSS.
Should we
I'll
go
show you that way too.
Should we go into Excel with you or should we? go
Yeah,
into
probably.
SPSS?
Yeah.
should we do SPSS?
I'm really not watching the language in this class for some reason. All right, so
Don't worry, we won't count on you.
I have academic freedom. It wouldn't matter if you did.
This isn't happening with software.
Oh, yeah.
I parabolically curved a grade for some other students at a different school earlier today because they did so poorly. Now they all have good
Wait,
grades.
you curve a lot?
No, not for this class
Why not?
because you got to know it at stats.
Does it matter whether we use Excel or SPSS in certain?
No, you
Like
can
this?
do it by hand, SPSS or Excel. What I would do, what would be the best practice would be use SPSS and Excel to check your work.
Okay.
I was still going to do it by hand because if you don't plug it in correctly to Excel or SPSS, you could get it wrong. If you know how the steps by hand, you're always going to get it right.
Thank you.
So should we do this in data view or variable?
We're not there yet, but I'll show you.
Okay.
This is pretty bomb. Watch. Okay. Excel. Right? So let's throw some numbers up there and we'll do the same thing on both your screen and your screen.
I can do it in SPSS. So I can do this, I'm in SPSS right now.
No, we're not doing that yet. We're gonna do that in a second. I'm gonna show you Excel and then I'm gonna show you how to do this in SPSS.
Okay, I'm opening Excel. right
So just open Excel and then we'll do SPSS next.
Okay.
Okay? So let's do some numbers. Let's give me a number, Marina. 22? Any number. Don't say a million. Keep it like in the hundreds or thousands, okay? Like
now.
it would still work. It would still work. It would just be a big number. I'm saying let's work with smaller numbers, just for simplicity. 10. 7.
I don't see
I'm
how-
typing on this screen, then I'm gonna duplicate on the other screen. Because Janessa's on this one, I'm gonna do both, okay?
Do 12,
22,
12,
10, 7,
19,
12, 19. I'm gonna duplicate these for Janessa. Give me another number.
42,
42,
39,
39,
48,
48,
54,
54.
78.
That's probably enough numbers. That's 10. So let's do the same thing.
I got all
12.
the numbers, by the way, just so you don't have to type them.
Okay.
I have them all on Excel right here. 42, 39, 48, 54, 78.
That's right. I know how to type them, but I'm typing them in case someone watches the recording later. Okay. So the sum of the values,
they give you,
you can just click auto sum right here. It's 331.
whoa, how'd you do that?
I'll do that again, but let me show it to Janessa, okay? You can take all of these, highlight them, and then you can go over here and just click the nice Sigma key, sum 331. That's your total right there. You can add them by hand. That's all I did. I hit the sum button over here in Excel. So what you can do is you can just highlight these and click auto sum.
Oh,
And then it does it for you. Now, if you want to be fancy, you can type in equals sum. And then you can do a range of the numbers like that. And it'll still give you that.
how we're gonna find the average? Did this thing do the average as well?
We're not there yet. You give me like a minute, 2 tops, you're gonna see that, okay? You can also take it and go like that. Total. But that's not our entire formula, is it? All I did was the numerator, the sum of the values. I got to divide it by n. Now, you can see, because these are numbered in letters and numbers, that we have 10 values. So we know it's 10. But if I wasn't sure, I can go over here. I'll show this to you too. And type in count. And I can highlight all of them except for our total. And it would tell me that my n is 10. So you could take and you could type in equals count. And then you highlight all those. Not your total, of course, because that's not part of your count. It would tell you that your n is 10.
Yeah, it's okay.
If you're wondering where these lovely Excel formulas are, why don't you click on announcements?
It didn't work on me.
These are all your Excel formulas.
Yeah, I know.
equals sum bracket.
Oh, the bracket.
And that's why I didn't like it. It was thinking it was a nominal variable or something.
It's not working for me. I'm doing equals count, and then I highlight them all, and then it says like name.
Let's-
hashtag name question mark.
Did you add the bracket?
Equals count. And you have to add brackets.
What do you mean?
Brackets.
Do you see it right here? See where it says n equals count? Like that with the brackets, that's the formula that we're using.
Okay.
Right there in the announcements.
Oh, you have them all.
Oh, it worked. It worked. You're right.
Janessa, if you click on announcements and scroll down, there's a list of all the Excel formulas.
These things you're doing right now on Excel, it's basically the same buttons and same everything for SPSS, right?
No,
Okay,
but it's okay.
I don't think I have Excel.
We're gonna do SPSS in a second.
Those formulas
So-
work in SPSS.
SPSS is what's your favorite car? What's your favorite car you want to try? The most expensive car, then it's the Batmobile of stats, okay?
Okay.
All right.
It's a very good example.
So we have 10. So what we know, so we just did this. The sum of all the values is 331, right? And our n is 10. So that's numerator, denominator. So it's probably, what is that? 33.1 is our average. Is that about right? So all I have to do is I can go into Excel and I can say equals. And then since we have letters and numbers, I can either type in 331 or I can say equals A11 and reference the cell divided by C1. Do you see how those are highlighted?
Oh my god.
Right? I'll show you that. So we can go equals A11. See that? Divided by C1. That's our average.
Basically, the numbers, so the column that 33 is on, and then the column that 10 is on, like where you're getting the.
Yeah.
11.
Yeah, or if you want to be fancy, you can type in equals average like that. You can highlight them and go like that. Did I just blow your mind? I'll show you that too. You can type in average and then you can highlight those and then go like that. And now you got your mean.
When you're doing it, do you need parentheses or do you need brackets?
Brackets.
Okay.
Brackets.
I don't have my glasses on because I forgot to grab
Oh.
them today and I like couldn't see whether it was a bracket or a parentheses.
Are you in Blackboard right now?
Yeah.
Click on announcements.
Okay.
And then scroll down past class meeting to Excel formulas. And they're all sitting there for you. Now, I'm not going to explain all of them today. Some of them are coming up later. I'm just going to explain the ones that we're going to use today, which are probably as far down as like N at best, probably just a median.
So how many formulas do you think we're gonna be using for like the whole course?
They're right here. So right here. Student resources, general resources, formulas, master list of formulas. It's open book, open note, you're welcome. All the formulas are right here and just the chapter 12. And those are all the formulas, period. Chapter 13, you don't have to worry about. Those are all the formulas. You do not have to memorize them. You can look at notes on the book. It's fine. Do you know where those are, Janessa? Student resources. Okay, general. Andy, question.
On the Excel, so another thing you're doing, it was like equals 11 divided by C1. It keeps giving me 1.1.
Did you put these all in the same columns?
Yeah.
Should be
Yeah.
like
So I just did equals, and then I did 11.
No.
divided by C-
A11. See that?
Oh.
I'm Excel is columns and rows, and they're automatically labeled for you. Now, I'm taking a shortcut. I could say equals 331 because I know that's the sum divided by 10. I would still get the same answer.
Wow.
Equals 331 divided by 10. I still get the same answer.
That guy. You're that guy.
Does that make sense? Yes, I am that guy.
Amazing.
So Let's talk about SPSS. So let's talk about SPSS. Okay. So I'm just going to take it down to our numbers that we came up with. And then I'm going to take and I'm going to save this file. I'm going to save it as somewhere I can find it. And we'll save it as SPSS example. Now this might break SPSS, but that's the idea. I'll tell you why in a moment, okay? So you can take and you can save this file and you can save as a workbook and you can call it SPS, somewhere you can find it. You can say SPSS example 1 or whatever, just you can label this file and just keep it just like that. And in fact, make sure you delete the total when you save it, just so you have just your numbers, okay? That'll make sense as to why in a moment. And then let's go ahead and open up SPSS. So I need to stop sharing with you so I can see SPSS.
Where do I find SPSS?
SPSS, you should have, go into your announcements and scroll down all the way to the very bottom.
Okay.
And there should be an SPSS announcement with a link. You want me
Oh, I
to,
see.
you see it?
Yep, I got it.
So that's your license code. Use the PKG if you have an Apple, use the EXE if you have an IBM. And then you're going to say that you're an authorized user and you're not going to sign into anything. You're just going to cut and paste the license code in and SPSS will install itself.
Okay, hang on.
And it'll be free. SPS is a big program. Depending on your bandwidth, this might take a while.
Yeah, no, it went from 4 to 5 to 3 to 4. It's fine. You can go on. I'll try to follow along.
Okay. I am recording and I can post this later in
Yeah, that's fine.
Blackboard. So I'm going to open up SPSS on my computer for everybody. And then I'm going to go into, I might have to minimize you just for, oh, I can't minimize. Okay. I don't want that crap. SPSS statistics, share desktop. Can you see that?
Yep.
Perfect. I'm
You
loading.
said when I save it as a download for the IBM, I need to save it as IMG. Is that what you said?
It's .exe. There's two files in
Yes.
there. It's the .exe.
Okay.
So I'm just opening up SPSS statistics right now. Now remember we had an Excel file and we could type all these variables into SPSS, but that's so like 2010, okay? Like, why would we even do that? That would actually take way too much time. All right, so all we have to do is go file, import data, Excel. We'll show you this in a second. And then do you see what I selected there, Janessa? And then I'm going to click open, watch. I'm going to blow her mind, then I'm going to blow your guys' mind, okay? Watch. Here it comes. Should work. Do you see that I just imported successfully those numbers into SPSS? Do you see that okay? Am I still screen sharing? Same thing here. File, import data, Excel, wherever the heck I put it. Downloads probably.
I think I saw it.
I swear I just saw it.
You have to go to like recent or something. Right there, SPS is example.
Sample, open, watch. We're gonna open the Excel file in SPSS. Bam, hashtag winning.
Oh my God.
So now we can click on variable view and we could label these like, we could say these are like ages or something of people. And then these are our ages. So we opened it. So now you said, can we do this in SPSS? Yeah, you click analyze. descriptive statistics, frequencies. Age, oh, it's that 20. So it's this variable. So I'm gonna change that. Variable view, I'm gonna rename this. I'm gonna call this ages. So now my data view says that. See, ages. Because I just changed it. Click on the variable view and we'll make this ordinal. Data view, same thing. Variable view with decimal 0, we can make this ordinal. Data view, ages. So all I do is import this. Yeah. Yeah. So let's go back to Excel for just a second. File,
Can we do it from Google Docs too or no?
I don't know.
Or the spreadsheet?
You'd probably have to download it for it to work because it's grabbing the actual like desktop file. So you can save as. But sometimes SPS doesn't like Excel files. So save it as a .csv, comma, separated values. So if you go back into Excel, you can also save it as file, save as, and then you get a drop down and you can make it a CSV, comma delimited. And then it basically changes the file format. It's more user-friendly for SPSS. So if you have an Excel file and you're like, this won't import, just resave the Excel file as a CSV file, and then it'll import just fine. So all we did is we opened the file inside SPSS by clicking File, Import Data, Excel, file type. You can actually select a CSV file if you wanted, and then you would just find wherever the heck we just saved it, which apparently I can't find now.
You know, just keep clicking next.
I just click next, like it's pretty intuitive. And then you can open up Excel in SPSS.
Oh, and nine.
So now you can take and you can ask SPSS to do stuff for you. Yeah. Yeah. And then, so we go analyze, and we go to descriptive statistics, frequencies, ages, move it over, hit statistics,
Wait. Analyze, and then we click what?
analyze, descriptive statistics. You can do descriptives or frequencies, either one would work. You take ages, which we labeled, which is this column, you move it over and click on statistics.
How do you name it?
You click on variable view.
Wait, sorry, what did you do after descriptive statistics?
Frequencies,
Frequency after.
and then click on statistics, and then check what you want. So let's just check the mean and click continue, and then okay. And then it gives you a nice frequency. Did I not do that right? I don't like that. Hang on, they didn't work the way I want it to work. Analyze, descriptive statistics, just try. No, not population, that's not it. Analyze, descriptive statistics, descriptives. Oh, why is that even appropriate? No. Analyze, descriptive statistics, frequencies, statistics, mean, continue. Okay, now why the hell is it not working? 78, where's our average? Why is that not working? Oh, because it's ordinal, it doesn't like it. Okay, that's fine. So we could just go file, new data. Let's just start over. Let's go file, new data. You can still import, but it's just not cooperating. So I'm going to do window, untitled. I'm going to go file. I'm going to go new data. I'm just going to create a new data file. Let's do some new numbers, okay? 12.
New numbers?
number.
On my SPSS, I don't see the words of icons of file edit view. And it's like,
So-
I'm not sure. Has its icons, but it doesn't give like the words to put on it.
So it's totally fine that you're here late. It's 100% fine. But the SPSS guy that helped with that specific thing was here at the beginning of the class, and then he left because no one had any questions. I will come over and look at it and see if I can figure it out. But if it's a software thing, I can get him or get him to do like a Zoom with you. Finish what it's doing.
No, like, insert and all that, just like, for that, exactly.
No, you're fine. No, you're fine. You're 100% fine.
I'm just.
Oh, it's because I had a bunch of questions when I created like. No worries, it's fine. So. Let's just create some new random data, shall we? 12, 24, 89, 87, 42, 36, 89, 50, 24, 99. So I'll put the same ones here for you. We did 12, 24, 89. Yeah, that's fine. 87, 42, nope, not 52, 42, 36, 89, 50, 24, 99. But that looks just like garbage. Let's clean that up. So let's change our decimals to 0 and look at our data. So let's change our decimals by clicking on variable view to 0. Okay, that looks a little bit less like garbage, but it still kind of looks like garbage. Let's label this. So we're going to call this ages of people. Data view, now it says ages. I'm going to do variable view. I'm going to click on the name. I'm going to type ages. So now we have some numbers that don't look like garbage that we've labeled. We've coded our variable by clicking on the variable view and giving it a name. We've changed the decimals down to 0. That's all we've done. Now we can change it to scale, ordinal, or nominal right here. We probably should. Scale, yep.
Everything you enter into the variable like section, it translates into the data view for anyone normal to read, right?
Yeah.
But for for example, the data view is the building, but the variable view is like the blueprints and the
Yeah.
okay.
Yeah. Yeah, that's 100% it.
You changed all the names. The ages.
Yeah.
Why?
Just to give it a name, just so it's
Or
easy.
no, why'd you change the numbers?
Because it was making them ordinal and it wasn't SPS wasn't cooperating. So I just created some new data.
Dude, you
What if
didn't fill
these-
me in on that.
You were here,
I
don't watch
wasn't paying
football.
attention.
Analyze, descriptive statistics, frequencies, take ages, move it over. I'll show you this in a second, Janessa. Statistics, mean, continue, okay. There's your mean. So I'll show you that too, Janessa, no worries.
Dude, this is nice.
Isn't SPSS the bomb?
That's okay.
It's okay.
Please,
Analyze,
please tell me
descriptive statistics, frequencies,
once we start like doing these like homework and stuff, you'll hold our hand the whole way through.
of course, I will.
Yes.
Statistics, mean, continue, okay. There's your mean.
I have a question.
Yeah.
When you're switching that over, when those two boxes come up, what is that? What does that do?
Where do you mean? Do you mean, so,
Go back to what you were,
so we go analyze
yeah,
in our menu, and you can do descriptive statistics, you can do descriptives, and you can do,
right. So what are
that-
those? What you just did right there? That with the arrow, what does that?
oh, I
do?
was moving the variable over. I was telling it what variables I want to do something with.
Oh,
So,
so when you move it over, then it actually makes it like in use.
It makes it so you can use it. So if I don't move it over here, I can't do anything. So I'm gonna move ages. I'm gonna click on statistics and I all these wonderful options. I'm just clicking on mean. I can do the mode and I can do a bunch of stuff. I'm just doing the mean and then I'm saying continue and then I'm saying okay, and then it's spitting that out in this new file, 55.20.
Awesome.
But is that correct? Well,
No, I would never change.
if we take the same information and we go into Excel, because maybe SPS, like, it doesn't have it together. Well, let's find out. So what did it say? It said 55.20, right? Do you have those numbers in Excel, Janessa? Or I can move them into Excel for you. If that'd be helpful. So I'm gonna go in, you can go into window, and then if you can just highlight them and then do Control C, and you can open up Excel and you can put the new numbers like that. Ooh, not like that. Clearly not like that. It worked on the other computer.
Can you just leave that up for a second? Because my SPSS, it downloaded, but I still have to figure out what to do. So we can do that in a little bit, but I just have to copy those really quick.
Put those in Excel.
Okay.
So then if we want to see if it got it right, we can take all this, we can auto sum it. And then how many do we have? Well, we have 10 numbers because we can see that. If we're not sure, we can hit count and we can ask Excel to tell us, but it's going to tell us we got 10. So that's our N, right? So then it'd be the same thing, equals A11 divided by D1. 55.20. That's what SPSS told us. Or we can type in equals average, preferably in caps, equals average.
Why there's so many different types of average? Like,
No, it's just the mean. And then you can take the range and it'll tell you the same thing.
no, it's like, can you go back and type average real quick?
Equals average.
Yeah, like 40 million different.
Yeah, we're not going to get into that. That's beyond the scope. It's other stuff in Excel, and I don't know the answer to it. I could research it and provide more information like next time. I know this average works. I don't know what the average A, if, and that's beyond the scope of my Excel expertise or the class.
So the average is.
Yeah, and then you just go like that. So if you're in Excel, it's the same thing even with the other data. You could take these and you could certainly auto sum them, and then you divide them by 10 or your numbers, or you could say equals average, and then you just put the range in on the numbers of the ones you have too, Janessa, and it'll give it to you that way. But you still got to understand what you're doing, because if you don't understand how to sum of the values, so like SPS is pretty awesome. Oh, by the way, SPS exports to PDF and Excel too. Yeah, I just blew your mind. I know, right? That's pretty legit, huh?
You cannot let the Fed get a hold of this.
They probably have it. They probably have it. So you said, how can we use stats in the real world? We have not talked about variance yet, but when we get to variance, I'll tell you how we use stats in the real world and why it's irritating me. Not stats, using variance with this one particular school that is like expletive Walmart. So not here.
Every time.
Ending in ing.
Every time he says expletive, he's trying to add a swear word, but he
Yeah.
didn't want to say it because we're children.
Is that the one school where they have the 2 different stats classes?
No, those people are crazy. No, not that school. There's this other school that, well, let me get to variance and then maybe I'll Chris make my point.
You said are we still gonna review from what we did last class? Cause
Yeah, I'm getting there.
40 million terms that I
Yeah.
forgot.
Yes,
Respectfully.
from current slide. So that is how we do that. So where is population and sample mean make sense to everybody pretty much? The formula? Okay. So I'm doing chapter 3, but as soon as we finish chapter 3, we're going to review chapters 1 and 2 before we do any worksheets. Like it's built in. Like that's the direction the lecture is going. Okay.
Will it always be like this? Or does it-
No, I review a ton.
Oh,
So what I'm gonna do, so I'll review all this and then we'll do chapter 4. Now, our first test will be chapters 1 through 4. But what we'll do is we'll do review worksheets as we get into the other chapters. And also I'll have you all present your understanding to each other of 1 through 4 before we ever get to the test. Yeah. People do it every semester and it's fine. Send an email, put that on a review.
No, because like, I know it's 4 hours, but like, to be honest, these 4 hours go by pretty fast, and I think, I don't know, for me at least, if we had another class, I think I'd understand it better. I'm just saying, no, I'm not like, I'm just
During the
saying.
summer, we do that, but it's condensed. It's 4 and 4. So this is like literally the same thing, adding all the numbers together, dividing them. This is the mean. This is what this slide means. Make sense? Okay. Weighted mean when there's 2 or more. So you take the mean of each sample, this is the formula, the sum of the mean times the number, the weight of mean of each size for the sample of the mean for their disproportionate size. We don't do weighted mean a lot in this class, but that's the formula for it. You can't really do that in SPSS. But that's okay. Let's walk through weighted mean. So I don't know if I can play this at the same time.
We already watched the YouTube
You
video.
watched the YouTube video, didn't you?
Yeah, we watched
Weighted
it
mean,
last
right?
class.
Yeah.
That was the one where like.
Yeah.
the
Yeah, we did
number-
that. Yeah. Okay. So the median, I recorded that, Janessa. You can ask me questions outside of class, any of you can.
Okay.
There's a YouTube video in the slides. If you watch that, it explains weighted mean. I would probably say that's homework for you if you haven't seen that yet. Like I would just look at that. Median, the middle value represents the midpoint where half the scores fall above and below. So if we have 34, 45, 60, 75, 80, 95, 105. The median position is right in the center. It's not affected by outliers. It's like you take a ruler and you move your hands toward each other. That is your median position. Not influenced by outliers because it's exactly in the middle. So if you got some random Yahoo over here, this is income, and he's making $1 million a year, and you got somebody over here that's making like $7 an hour because they're wait staff and they're being underpaid, or $4 an hour, whatever it is. These are outliers. They're in the low and the high end of things. The median position, it doesn't matter because it's an exact midpoint. And average is affected by outliers because it's the average of everything. So when we talk about central tendency, it's like, how is stuff behaving? How is stuff behaving? So the median position is n plus 1 divided by 2. It's slightly different with the calculation. It's not influenced by outliers. You always begin by placing scores in numeric order. So for example, if we have the median with n is odd, and we have the following scores, 99, 64, 13, and 8, the median position, because there's 5 scores, 5 plus 1, which is 6, divided by 2, which is 3. So the median is 44 because it's the third number in the position of the numbers. Does that make sense? Because it's odd.
Why do you add the 1?
Because it's odd.
Oh, okay.
No, well, you do when it's even too.
So it's just like a rule.
It's just a rule, yeah. And it's yeah, same thing. Find the median for the following scores. There's 4 of them. 4 plus 1 divided by 2, because we're trying to find that's the formula. So it's a 0.5 position. So 66 plus 44 divided by 2 is 55. So it's within the list of numbers. It's like moving from the left and right all the way right to the center. That's why it's 55. Does that make sense to everybody?
Wait,
That's central tendency.
you said for this one, 99, 64, 44, and 13. You said the median was 55?
Yeah, because there's four numbers.
Yeah.
So we took 4 plus 1, n plus 1, and divided by 2, which is the 2.5 solution. So 66 plus 44, because it's the two numbers, 2.5 between the two, divided by 2 equal to 55. So it's the right in the center solution. Because we're moving like towards this is and all, so mean, median, mode, these are all central tendencies. Like what is happening, where is the like the average or the midpoint, like where is kind of like the middle of the data, what is that telling us? And that shapes what the curve looks like. We'll get to that. I can keep that up for you. Just tell me when, Janessa. Okay. The mode. Are you good? Okay.
You're good. Yep.
So the mode is just whatever score you see the most of. So in this case, it's 4 because there's a ton of 4s. Now you can have a multimodal score. You can have more than one mode. It's whatever number repeats the most, or if we have 2 or 3 modes, it'd be something like this: 1, 2, 3, 3, 3, 4, 4, 4, 5, 6. Well, we're gonna have 2 modes because 3 repeats 3 times and 4 repeats 3 times. You could have this 10 times. It's whatever number repeats the most and whatever number matches the amount of it repeating. So if the number repeats 20 times, another number repeats 19 times, that's not another mode. It's whatever the maximum amount of the same number is, or if there's multiple ones that repeat the same exact same amount of times, it's multimodal. And then it looks like that when it's multimodal. Enters how you, because it has a mode shaping the graph. Make sense? Don't worry about this. This will be explained in detail later, okay? Mode makes sense? Nessa? Okay.
Yep, you're good.
Okay. Some characteristics of the mean. Increasing the value of these are just rules. Increasing the value of an existing score, the mean will increase. That would make sense because your sum is going to be higher and then you're going to divide by the same amount of numbers. So if you increase one value, of course your mean is going to be higher because all the numbers affect the mean. If you decrease the value of any one of your list of scores, the mean is going to decrease because you're going to get a lower sum and you're going to divide by the same number. So if your sum of all of them is 20, and then you decrease one of of the scores by 1, and the sum is now 19. Well, and you got 10 scores, your new mean is 19.10, or on the first one it would be 20. We had 10 scores. It's the same thing. If you increase it, and this suddenly becomes 22, well then maybe it's 2.2. So if you increase a score, the mean increases. You decrease a score, the mean decreases. Make sense? Okay. Add a score above the mean increases. Add a score below the mean decreases. All we're talking about now is the average of all the numbers. If the new score is an additional score above the mean, it increases. You add a score below the mean will decrease. So like an extra score will pull the mean up or down. Makes sense because outliers affect the mean. Delete the score below the mean increases. Delete the score above the mean will decrease. That would make sense because of what that would do to the sum of the numbers. Add or delete the score equal to the mean does not change because it's already the average. So if you add or delete a score that's right at the mean, it's going to just keep it the mean because there's going to be one more number and there's not anything above or below it to pull it up or down, so it's going to just stay the same. So if my mean was 20 or 22 and I added another 22 and then I divided by 11, it's just going to factor that 22 out because there's one more of them and it's right at the average. adding, subtracting, multiplying, or dividing each score into the distribution by a constant will cause the mean to change by that constant. So you go to McDonald's because they're the most wonderful company in the world.
I thought you were gonna say maybe because you're like the only place open after this class ends.
No.
Uh,
Meal with French fries, 450 calories. Meal without French fries, 350 calories. If you look for our mean here, when we decrease them by 100 across the board, the mean decreases 100 total. That makes sense because it's just the addition and then the division of the number of them. McDonald's is incredibly unhealthy,
Yes.
which is why I think that they're fundamentally evil and bad. The McDonald's inside the Walmart, because Walmart supports child labor, is even more evil because now it's bad health and they're supporting children with the small hands needing the clothes that you're wearing. Okay,
If you wanna buy from McDonald's, don't buy from McDonald's.
I don't buy from
Yeah, no,
McDonald's
but you're
Yeah, I'm
saying,
saying they're
you're,
evil.
you're saying it's evil.
because it's unhealthy.
If
That's
that was the case, every single like company that makes like processed foods.
it's pretty bad.
Definitely bad.
Apparently, or we're bad.
No,
We're
I
bad.
agree. McDonald's very terrible, disgusting, like disgusting. It makes me feel sick. The chicken nuggets. Come on.
Yeah, I would.
Evil
I
tastes
could.
good.
I could go through the drive-through right now for those.
Evil tastes good.
I mean, I'll be honest, chicken nuggets for like $1 can give you 4 of them. That is not chicken. That's like frog or something. Like that's $1.
It's probably cloned. Okay.
Evil is cheap. It's good.
Oh my God.
So the sum of the differences from the mean is the only constant where you subtract every score in the distribution where the sum of the differences are equal to 0. So the sum of the values minus the mean, that's how you represent it, it will be 0. The next slide makes more sense. So we have X value of 1, 2, 5, 7, 10. The sum of all of those are 25. And then if we take and we divide by 5, we know the mean is 5, right? That makes sense. So this other column here, we take 1 minus the mean, -4, 2 minus 5, -3. So all we're doing is we're taking this value and we're subtracting the mean from it. When you do that, you get these numbers, you add them together, the sum of the values minus the mean is equal to 0. Yeah. When you're going to calculate variance or standard deviations, which are coming. But I'm going to walk you through it. You would absolutely use it. It's a way to figure it out in Excel. When we square stuff, you'll use it. We will go step by step. I'll record it all. You'll absolutely get there.
When you
But that's coming. That's like 2 or 3 chapters. That's not.
Okay, I was just asking.
Yeah.
when you plug this in and you're doing it like on the right side of the table and you're completing the problem, what are you looking for exactly?
This is just a characteristic. This is just a rule of the math. If we decide to subtract the mean from every single score and then get that number and then add the scores together, the sum of all the scores minus the mean is equal to 0. It's just a characteristic of the mean. We will use it, but we'll use it much later. That's probably a better answer for you. The first one probably for each.
So I'm
Sorry,
just like kind of ahead, like.
kind of ahead of yourself. It's coming though. You good, Janessa?
Yeah.
So the sum of the squared differences don't let squaring freak you out. All squaring is just taking the number times itself to the second power. That's all it is. Like 5 squared is 25. That's all we're doing. 5 times 5, whatever. So the sum of the square difference to the scores of the mean is minimal. To obtain a value greater than 0, square each deviation before summing. This produces the smallest possible number greater than 0. So the sum of the value, which is x, minus the mean squared is the smallest positive number you can get greater than 0. We'll use this more later. That's what that looks like. The sum of all the values is 25. So the smallest possible solution is 54. And subtracting other value, then the mean will produce a larger solution. So in this case, we're just taking the value of X, we're subtracting the mean. So 1 minus 5 is 4, and then we're squaring it. 2 minus 5, -3, we square that, it's 9. 5 minus 5 is 0, 0 squared is 0. 7 minus 5 is 2, 2 squared is 4. 10 minus 5 is 5 squared is 25. The sum of that's your smallest solution, summing the values together. It'll make more sense later.
No, this makes sense.
Okay, okay, cool. When do we use mean? Mean is reported for normal distributions of data. Normal distribution, that is when it's symmetrical. What the hell does that mean? Well, symmetrical, that means your mean, your median, and your mode are all on top of each other. That's your central tendency. If it's skewed, it can be positively skewed or negatively skewed, where there's more there. What that looks like, it looks like this. So I think if I give you a visual, it'll make more sense. Normal distribution. Images. Skewiness is 0, that's normal distribution. This is the best one. There's your positive skew, symmetrical distribution, and negative distribution. Right, the bigger maybe? No. Yeah, negative and positive skew. So when your mode is here, your median's here. Hang on, I'll show you. All we're talking about is this, is the skew. So that's normal distribution. I don't want that. Normal distribution skewness. Share. Let's just do desktop so you can see everything. Share. And then you can see the desktop. You can see my.
Yep.
Okay, so if I just click on, what I'm showing them is I'm showing them images,
Mhm.
images for the skew. So this is a good example right here, or this one right here. So if the mode, median, and mean are here, if they're symmetrical at the right at the top, or if they're that's what produces your negative and positive skew. So this is your central tendency. So they change the shape of the distribution based on where they are. So your positive skew, your modes to the left, medians are in the center, means to the right. They're on top of each other for symmetrical. So it basically pulls on this in terms of what it does. Your negative skew, your means to the left, medians in the center, modes to the right. Central tendency, it shapes, changes the shape of the curve. We're going to primarily deal with normal distributions in class, but that's what I say when I say normal distribution. I mean a normal bell curve. How are you guys doing? You guys need a break? I know it's been like, it's kind of getting that vibe. You want to take 5 or 10? What do we need? 10? Yeah, let's take 10. So it's 7:39. How about you come back at 10 to 8? Take like a solid 11 minutes, okay? Kind of getting the vibe, we could just kind of use a break. I think you guys are getting it, but let's take 10.
I was gonna ask you really quick. So I did the pre-test and post-test
Mm-hmm.
for 2, and it said it was late, and it just gave me no points. So I don't know if you still have to go in and grade that yourself, or if it just.
I think so. I either have to update it so it doesn't say that, but with the pre-test and the post-test, and for you to see your score, I have to basically go through and hit save.
Oh, okay. Because I thought even before it usually shows it like right before you go back, it'll say you got this out of this. But it didn't.
Hang on, I'm gonna pre-test and post-test 1 and 2.
Yeah, so I did, one
Okay.
is fine. That one, it did the same, it showed the points, but then when I did two, it said
Okay,
0 out of everything, so I wasn't
I can
sure
fix
if,
that. That's like a Blackboard setting.
okay, do I
Pretest
need to
and post
retake
test are
it
both.
then?
Edit. Not add, edit the test. It's edit the test options. That's why.
Yeah, what,
Let's try it now. I just fixed the pretest. I'm gonna fix the post test right now.
okay. Because mine is even still saying like, post test 1, it's telling me it's due June 17th. I don't know if that matters.
I'm changing those due dates right now.
Okay,
On my side administratively, I'm changing the pretest. I'm making them like due a couple days from now. Test options.
oh, okay.
And that's probably why it's doing that.
So
So
then will I have to go through and retake it?
no,
If it's test
no.
post, or if it's post test 2, then I'm totally fine with retaking that one.
Well, it'll redo your score.
Okay,
Whatever your highest score is what it'll take.
okay.
Test options. And we'll make this one due Saturday.
Okay.
So I just did that for I just gotta do the post. You said you can see the post test fine though, right? On the chapter
Yeah.
1.
No, I can see all of them completely fine. Post test 3, I couldn't get into,
Let's see what.
or I mean, pre-test 3. I could through the, like the, students thing, but is
I'm
it
looking
not
at it right
clickable?
now.
Okay,
Retest chapter 3. Edit the test
Yes.
options.
let me make sure.
Oh, that's why. No, that's not checked. That's
Okay, I can get
okay.
in.
I'll try chapter 3. Chapter 3 should be fixed for the pretest.
Yep, it is. I just was able to get into it.
Yeah.
Okay,
It was a setting from there being a due date of last year because I built this class by hand from the beginning and I've added stuff to it since, and then I make a copy of it every semester. And sometimes it pulls old due dates in until I update them
Mm,
because it's a
okay,
copy.
that's fine. I just wasn't sure.
I'm not feeling great today. Is it okay if I leave early? I'm gonna try to stick it out for the
Yeah.
class. I just,
100% fine. I'm recording everything.
okay, that, I was gonna ask, cause I would have just stayed home, but I wasn't sure if you were recording, and I was like, if he's not recording, I'd rather just go late in person.
No.
Um,
I'm generally always recording, especially for stats. Once in a while I forget, but generally.
Okay,
And if you're ever worried about that, you could send a text.
okay.
Email's 100% fine. I just see text faster.
Yeah, I texted, but I was like so close to when class started, cause I was like
Oh.
just planning on going on to Zoom.
And I end up doing Zoom like 18 minutes. Usually, so what ends up happening for me is I teach till 5:45 at the other building.
Yeah, no, I know. It's better to do it in person anyway, so I was like, I was gonna either just like watch the recording later or like come in person, cause Zoom is not the best for me to like
Okay.
understand it, so it's fine.
I do have a whiteboard though. So I was showing her earlier, but see, I can actually pull up a whiteboard and I can draw
That's really nice.
stuff on it,
Okay,
and that's included. It is stats, so it's probably better if you come to class than if you don't, but I'm recording.
okay,
And then I'm usually posting the broadcast to YouTube and or Blackboard.
Okay.
And then I posted, if you go to lecture recordings,
okay,
I have, I think everything, but I actually put last summer stuff on here too. So you literally could go back and forth in time. If you start at the very bottom and moved forward, you would get the entire class.
thank you. So I'll try
Yeah.
to, I'll try to like. make it class, but
Yeah,
if I
it's
don't,
however you feel.
Yeah,
yeah.
I don't think it's, at this point, it's probably. It's just a little stomach bug.
Okay, that's fine.
I'm still here, by the way. I just blocked my screen.
That's fine.
I'll turn it back on when break's done.
Okay, cool. Be right back. Oh, you need something?
Yeah, what I can tell you, on my icebreaker, I added a link to where, I don't know.
We'll then find out openable, and if I can't see what you submit, I can't see it.
Oh, no, like, this is my original temp,
Then you didn't,
it has this on it,
I didn't, okay.
like something.
So either
It's not this exactly on the link,
So
like I wrote this and then the link has the following.
oh,
I'm gonna
okay.
Reply to your email,
Just reply to my email
okay,
or if you want,
Resubmit
if you just resubmit the exact same thing, I'll automatically put Blackboard to grade. And I'll watch the link this time, as long as I can see it. And you've done all this stuff, especially for the iceberg, you get the points.
okay. And then see it?
Yeah, it should allow a resubmission. Probably not there, I probably walk out of there.
Oh,
And
okay,
then-
yeah,
and then you
on the
should-
actual thing.
Yeah.
Okay.
Does it make more sense? So when do we use this? Normal, so the mean, if it's normal distribution, that's that thing I just showed you where the mean, the median, and the mode all fall at the very top, like right in the center. So it's a normal distribution. And we use it for interval and ratio scale data. And that's so that we can conveniently, so we can talk about like the meaning. So interval and ratio data will use the mean in terms of whatever we're looking at, like a psychological lens. We use the median
Yeah.
for skew distributions of data. So when the data set it was positively or negatively skewed, where I was showing you where it was like left or right, it's not influenced by the value of outliers. So when the scores fall substantially above, positively skewed, or substantially below the scores, or we use it with ordinal scale data, and that's to convey direction only, not distance. So because of the distance of the ordinal scale from their mean, not meaningful, median is used to describe these data. So like a ranking, we're using the median. Because the distance from the average wouldn't make any sense if we're talking about ordinal scale, because it's an ordinal scale. We have a worksheet where we're going to walk through this, by the way. And then I'm going to walk you through the answers as to why we do those that way. Mode reported for, so unimodal, one mode. So the repetition of the number one time. Bimodal, two modes. Multimodal, more than two modes. Non-modal, no mode. Mode is just a repetition of a score multiple times. If we have scores like this, 5, 7, 8, 9, there's no mode because they all repeat equally. As soon as we have 5, 7, 7, now we got a mode.
So you would refer to this set of numbers as non-modal.
Without that 7, yeah, that'd be not,
without
yeah.
that.
Yeah, that'd be non-modal. And we use modal to describe nominal, label, adjective, qualitative data. We use the mode. Why does that matter? Well, I think about my student that did the study of gang dissidence, why people exit gangs. The reasons were they found God, they went to jail for the crime they committed, they had a family, they had a child, and it was very modal because she looked for the repetition of the same sort of answers in her qualitative study. So she could say, the themes are, they tend to do these things to exit the gang. That's why you use a mode to report qualitative or nominal data. And that,
So a mode is like what you just said, in that specific situation, it's like a universal quality or universal characteristic.
it's a characteristic that kept getting, she was looking for like saturation of like the same reporting things. So she was using basically multiple modes because it was like 3 to 5 different things that caused them to get out of the gang. Like they became a parent. Maybe you're not a good role model if you're a gang member and you have a child. You got in trouble for the crime you committed for your gang and you went to jail and started working out and reading some religious text that changed your life that got you to follow a better path. You got married and romantically involved with someone, so you decided maybe being a gang member wasn't a good idea because maybe your partner didn't like it. You found God, you had a spiritual experience, all modal nominal things in her study.
Bless you.
But she looked for the repetition of that modal. If somebody said some random reason one time, she didn't really include it. It was like, what are like the themes that happen the most? Stop. Share. So I think we'll do review and then we'll end with worksheets. That'll probably make the most sense for everybody. Start, desktop, share.
In the syllabus, you told us how you grade everything, right?
Yep. Yes, absolutely. It's about half of your grade is your ability to do homework and do it correctly, and about half of your grade is your ability to do the tests and the quizzes correctly. So if you're a bad test taker, but you do a good job at homework, you're probably not going to fail. But if you don't do any homework, you only do well in the tests, you might end up with like a C. Does that make
Homework
sense?
is off of like the amount right?
Yeah.
Correct.
Yeah, the amount correct.
It's not
But
based on completion.
but I walk you through all this stuff. And then you have WebAssign.
And it shows where to find them. So, yeah.
Yes, so the WebAssign, I import that. All the homework we do in class. So if you watch the recording or you come to class, you're probably gonna know the steps correctly. Andy,
Are the tests, we take them here or online?
you take them online,
Okay.
with a limited time on your own. I'll give you a deadline. But I'm sure you're all honest people and no one would ever cheat, but it's absolutely impossible because your tests are not the same. They come from a test bank and they're all randomized, and test 1 and test 2 is the same content, but it's not the same test. So if you're like, oh, I'm gonna be slick and I'm gonna take pictures of what I got wrong. Yeah, test number 2, not a thing. If you're like, oh, we're gonna tell each other our answers, yeah, you're not getting the same test. Like, it would be so time intensive and the test match, because it's like a bank of like 1,000 different problems, and then it's randomized for the chapters, so it's still the same content. They're different.
If you like take test 1 and you look at your like score, does it tell you which ones you got wrong?
I think it does.
But it won't give you-
It probably won't give you the answer.
Okay, but it would tell you which ones
You got wrong, so you could study that part of the chapter before you take attempt 2,
Okay.
and then it's the higher of the score. So if score 1's higher or score 2's higher, it doesn't matter. It's whatever the highest score is. And I put that in a setting in Blackboard for Blackboard to automatically accept. It's like an if formula. If this is higher or lower.
Let's say that I took the test this morning,
Mhm.
and I go back to it to take it again, I can't see which one that I got wrong again, right?
No. But you would get a new test and it'd be the same material, different problems. And that, 2 attempts, but you still got a limited time.
Two attempts on, like,
The exams,
Yeah.
you get a limited attempts on the pretest and the post-test.
And it's open note.
Open book. So if you want to take 5 hours teaching yourself stats, good for you. Cool. What you can't do, don't have someone distract you and walk away from Blackboard. Okay, if your family or your partner or someone wants you to like leave the test and go shopping because you have a limited time, that's a bad idea, because Blackboard's gonna log you out and now you've burned a test attempt. Yeah.
Well, I don't know if that's the long now, but I went and made food for vodka and the test and saved all my answers. I have free ocean.
Yeah, it says you can.
Really?
Yeah,
You can pause it and then go back to it.
I haven't tried that with the other side.
It- Oh, well, if Blackboard will let you do that, by all means. My understanding with Blackboard is if you just like forgot about it and didn't save, that it would just,
So there's like a save and exit option.
it just save and exit then.
Would you like be lenient towards like if I was taking my test and then the power went out?
Yes.
Because like, I don't know why, but that's been happening at my house. It happened like 4 times yesterday. While I was trying to take my pre-test.
If something off the wall happens and it doesn't happen on all 3 tests, because then I might be skeptical.
Yeah.
Okay. I don't think you would do that. Yeah, then I will work with you, or I'll say, okay, I'm gonna add an attempt because the power went out. Yeah, that's fine.
Because like, I don't know why, but like the power downstairs keeps going out and then it shuts off the internet.
That's fine.
Okay.
Yeah, that's,
Just like if it happened my pre-test yesterday, and I was like, oh no.
I hear things from students and I don't even know why I hear these things. And I'm not talking about, like what you're talking about. I'm talking about like, I hear stuff about professors that like, they're mean, they're not helpful, they don't teach, they just read a slide. I hear stuff from like my student body at multiple places. I'm like, would you just freaking teach and make it easy? Like I hear stuff where like, I'm like, that's like complaints. I'm like, why would you do that? Conceptualization and measurement, part B, reliability. Conceptual variables, operational definitions. This is, let's say we have intelligence. How do we measure intelligence? Well, we might use a tool like the Fagan Infant Novelty Preference to measure intelligence. You don't need to know what this is. I'm just giving you an example of psychological measurement. So an infant gets exposed to a stimulus for 60 seconds, familiar with the stimulus presented with a new one for 30 seconds. time looking at the novel stimulus, novelty preference, average over 10 or 20 pairs of stimuli. So when we're thinking about a variable is anything that you want to measure and want to think about how to measure. What's so funny? Okay. I hope it was the video from last week. Is this a good measure of intelligence, validity? What do we mean by good? Well, reliable and valid. Reliability, again, that's consistency of results. Validity is, did I measure the thing accurately? So if you do a test and you like the results, that doesn't mean it's valid. It just, but if you measure whatever you're looking at correctly, then it is valid. So they can tell infinite novelty preference, probably. Reliable, again, is consistent. Valid is accurate, true connection. So just like review from chapter 1. Pretty soon you're gonna have to tell us the story if you keep over there with the smiles, okay?
Should I just tell her now?
What's the funny thing with your nephew? Yeah. So you don't distract us the whole hour.
I think you have to be there for it to be extra funny, but it was yesterday. So I came home and we were eating, and then he got really mad, and then he's 2, so he starts whining, crying, and then I don't know. You guys are probably not gonna laugh at this, but when he was mad, he kept slamming the table and crying, and just watching it was so funny.
All right. I can say it can be funny.
When he's sad, like when he's mad, I don't really feel bad, just funny. It's hilarious.
Sounds
The
funny.
way he cries, it's great.
You asked.
All right, that's fair. Yeah. So I remember I had a friend who had growing up as a kid, this 2-year-old. This 2-year-old was always like off, like in the background doing stuff. So I swear every time, and maybe it was once, maybe I had the memory wrong. We went to his house and my dad's like one of his like business partners, just like talking to him. I'm like older, I'm like, I don't know, like an early teenager or like 9 or 10, I'm much older than this 2-year-old. And you would just feel like there's a random crash because he'd be knocking stuff over. And then he would start laughing because of egocentrism, because he thinks his view is like the best as an infant. So then his dad would start screaming, quit laughing, it's not funny. And he'd like just like glass shells, like just like hilarious, which it probably was for him, but wasn't so funny for his parents. So what could go wrong? To your point, the infant could be cranky or sleepy or bored. So we could not measure it. We cannot measure it correctly. They could have poor vision. They couldn't see well. Raters pay more attention to cute babies. So there's something interesting, just psychologically. People that are good looking get less. Their sentences are shorter. It's a thing, statistically speaking. There are a whole bunch of measurements done and case studies, and that's so like whack and wrong. But they did a study of people that were like considered what would be called like not good looking or ugly versus good looking, and the better looking people got way shorter sentences than people that weren't as good looking by judges, like out of like hundreds of studies.
Wow.
They get shorter sentences in jail. Yeah, it's a thing.
Oh wow.
It's not right, but it happens. Like they looked at like statistically, like people like things that we would like value in terms of like good looks with both women and men, and being pretty does pay because you get less time in jail. It's a thing, statistically speaking.
Like a subconscious thing, or like it's consciously.
I think it's subconscious because like, oh, they're not so bad. They're good looking. Stupid. Doesn't even make sense.
I believe that.
But it's totally a thing. Raters work better with calm babies. Creative babies like novelty. ADHD babies like novelty. So this could totally make your test not valid or not reliable. Babies used to like TV like novelty. Used to TV like novelty. So measure is a true score plus the amount of error. You could have random error, like the infant's cranky or bored. You could have a bias, cute baby, shorter sentences for people with shorter jail sentences. Other variables, things you didn't account for could make it valid or unreliable. Like that could cause a problem. Threat to reliability, random error, consistency of results, threats to validity, other variables, like you didn't account for things. So the color codes make sense? Does that help? Okay. Random error, inconsistent balances out. Bias, consistent doesn't balance out. So inattentiveness, self-promotion, transcript error, mark the wrong answer, comprehension difficulty, all could like change your results of measuring that. So some of validity. So inattentiveness, random error, self-promotion would be bias. Transcript error would be random error. Comprehension difficulty would be bias in terms of not measuring their intelligence correctly. How do we measure reliability? Test, retest reliability, or can we get the same results over and over again? Or we think about stimulus checks, were they very reliable? I don't think so. What do we get, like 2 or 3 of them over like a year and a half? They would have been reliable if they came every month because you could rely on them. Reliability, consistency. Inner item reliability. If you're watching any of those like shows where they rate people, you ever notice the judges always tend to rate them about the same, or like Olympics and the skiers, inner item, internal reliability. Sorry, inner observer, inner rater reliability. Internal reliability is a little different. We'll walk through that. Alternative forms of reliability are always, but I'm gonna walk through what each one of these are in more detail in a moment. These are just like your list of ways you can look at reliability. Remember, reliability is consistency. So test, retest reliability, give measure, then give the same measure again to the same people. Calculate consistency. Use Pearson's R. Don't worry about that. We'll do that later. For most variables, it should be pretty high. Reliability should be greater than 0.880. That's just like a standard for the social sciences. Test, retest reliability is not always viable. You could have rapidly changing variables or states. For example, political attitudes, current emotional state, that can all affect reliability. Or you think about the infant slamming like your story. Try giving him an intelligence test. You're gonna have pretty unreliable results, right? Retest reactivity. If you're testing a bunch of subjects and they're irritated that you're testing them again, they could bias the results. Boredom, strive for difference or consistency. Yeah.
When you say retest, every single variable has to remain the same, including the subject?
Yeah, for test subjects. Yeah. Yeah.
Like, wouldn't it be more reliable if you were to change the subject?
You could do that, but they need to be, the demographic better be pretty darn close or it wouldn't make any sense.
Well, I mean, like, if you're retesting, specifically on infants, then infants are like, not like the same age.
Then you would test new infants. You want this, you want to like retest like the same, either the same group or a very similar group for it to work for the consistency of results. Like if I said you're all freshmen and I tested you, and then I wanted to see if freshmen the next year had the same attitude, we were all sophomores, it wouldn't make any sense. I'd have to test different people. Inter-item reliability, correlations of items in the measure, split half reliability. 10 items on a self-report measure of depression, consistency between the first 5 answers and the second 5 answers. That's what split half reliability is. So you take the first 5 of them, you see what the consistency looks like, you hit the second 5, and then you see if there's consistency between those two. Well, you can use Cornbeck's alpha, internal reliability, that has the average relationship of items to each other. So what this does is this eliminates things like double-barreled questions, like you're asking the question the wrong way, your answers are a little weird. This looks at the internal reliability. But again, split half is probably the best way. So we're looking at, if we're using multiple scales to measure something, are we using them correctly? So if we're thinking about like subjective well-being, couples happiness, things like that, and we're asking them a list of questions, we're making sure that all the items that we're asking them make sense, or the 4 or 5 questions make sense. We're also asking them about how they feel about each other separately, because they're going to lie if they're in front of each other. I mean, really. So, for example, these would be like items And then we would look at the forms, original and alternate, and we look at how much reliability there is. This really you should just be thinking about this conceptually, not necessarily like all the numbers mean. So you could have two more people do the same readings, can be done by live videotape transcripts, calculate the correlation. If the ratings are nominal or ordinal, you can't use Pearson's. This is fake data, but it's the idea is this is an independent test of retest reliability. Test, retest, we get the same results over and over again with consistency, reliability. Alternate forms applies to standardized tests where the researcher wants to have more than one version of the instrument. Why? Well, you can avoid cheating. For objective tests, be able to retest the same participants, avoid boredom and response set. That's why you get different tests, exam one. How to do it, give the two forms the same group within a short time period, look for consistency between scores. So you have a reliability problem. Assess reliability, you're looking for your test, retest, internal reliability, and inter-rater reliability. Is there a problem? So an arbitrary rule of thumb, R should be greater than 0.70. Find the source. Do we have inconsistent observers? Do we have inconsistent testing conditions? They did a really interesting thing at the 2016 ADNIC conference. Took a bunch of students, put them in a room, and they said, "Did you guess the story yet?" They said, memorize this information. We're going to go to lunch with each other, memorize the information. We'll test you in the evening. Then they did the same thing with another group of students, and they came back. Group A got tested in the same room. Group B, they gave them inconsistent testing conditions, and they put them in a different room. However, the group where they changed their environment, they actually scored higher, which is not everything you've been taught about, like study.
What do you mean by changing environment?
They put them in a different room. That's it, and they scored higher. Similar like backgrounds, all college students, similar ages. Inconsistencies in the participants' behavior, that would be reliability problem. If you're measuring something, inconsistent items, you're measuring them differently. Other problems with the observer, the person that's rating isn't trained correctly. You can simplify their task. For example, why don't you count the number of things rather than rating them? You can use instruments to record the behaviors that are consistent. Testing conditions, standardizing it, clarifying instructions and questions. Like I had somebody take a test when I used to work on the administrative side, and it was like from the Noel Levitt's learning nerds. So it was like 85 questions, and I was reading him his results, and he's like, "That makes no sense. That makes no sense." And I was like, "Okay, well, how long did it take you to take the test?" "About 5 minutes." "Like, were you just trying to get through the test?" He's like, "Yeah." I'm like, "Well, you need to retake it slower and be honest with your answers, because I don't have correct information, because everything you're telling me makes no sense. You can have a week, I'll call you in a week, retake the test." Unruly participants, like your FU. Okay. Obtaining measures of the construct and average together, a scale. On any one item, some random error, the way they read it, how much attention paid. If the random is error, some average should smooth it out. However, make the scale too long and errors due to boredom or motivation may increase. Like, it's like survey exhaustion. If you have somebody take like a 10 or 15-minute survey, they'll probably do it. You give them an hour survey, they're gonna fall asleep at the wheel. To increase reliability, we use multiple items. Some items produce no variability. Identify items that don't correlate well with others, dropping or improving items. That random measurement thing didn't make sense. That affected my reliability. So we're just thinking about this conceptually, like what would make your results inconsistent. So let's summarize reliability. It's the opposite of random error, test, retest. If R is greater than 0, good reliability. Inner item, that's like you have you have like tests, like items 1 through 10, first half, second half. More consistent setting, more consistent motivation, better rater training, item analysis. Did I have some random oddball thing I surveyed that didn't make any sense? Those all affect reliability, consistency of results. Inner observer, like, are they all trained? Do their ratings make sense? So reliability making more sense now. It's a real granular version of that. And let's go back here. Oh, we're killing it, guys. We got plenty of time. We're gonna be like so through chapter 3 before you leave, maybe even on chapter 4. We are doing awesome.
We're in chapter 4.
No, we're on chapter 3. Possibly. No, this is not chapter 4.
I'm just curious.
Because I hijacked something, okay?
Like, it says chapter 4, like I'm like crazy.
No,
I
you're
thought
not.
it was chapter 4 too. It's totally fine.
Some other lecture stuff that has from a different stats course that I taught from a different school that I imported and brought into this class to make things more clear for you guys.
Okay.
And that class happens to be chapter 4. We are still on chapter 3, okay?
Should I write this stuff down?
It depends on how you learn. This is all in Blackboard. It depends on how you learn. If writing stuff helps you learn, write it down. If you do better paying attention, just pay attention.
Well, like, it's like important stuff to write down for later. Or is this?
It's all in Blackboard, so it depends. If you're gonna write it down, it's gonna help you remember it for the test, great. If you're gonna refer to your notes that are in Blackboard, because I posted it, then it wouldn't matter. It's whatever works the best for you. For me, I do well paying attention with or without taking notes. It depends on what you're the best at. I would probably write it down so that you're not watching TV. So I'm
Like,
just,
some of this stuff doesn't seem like we're gonna need it, you know?
no, I'm just trying to give you a sense. So validity, face validity is like logic. Like it's not even that scientific. It's just like, does this thing make sense in terms of this measurement? And then you get into things like content, construct validity, and criterion validity. So face validity, does it appear valid? It's real, like, does it make sense? Or does it sound like it doesn't make sense? That's all face validity is. It's basically just thinking through the logic, does it make sense? It's pretty worthless, other than it's just logic. Lots of measures seem reasonable or nevertheless invalid. Many measures turn out to be turned out to be valid. So for example, intelligence, Fagan infant novelty preference. Does a measure cover the full range of the concept? Fluid intelligence, concrete intelligence. Does it cover every way we can look at it? So high concrete intelligence, high score, high fluid intelligence. Are we looking at the items that go together, the subcomponents of the scale? Are we measuring the thing correctly? So we're digging into the granularity of it making sense. Does it correlate other ways to measure the topic? Or is it similar to other instruments that measure intelligence? For example, the Stanford-Binet IQ test. Do those two tests look similar? Do they correlate with other ways of measuring the same topic? And let's say for the sake of argument, they're both measuring processing speed and your ability to solve a puzzle. Then that would be consistent. If they're measuring different things, we have a problem. Convergent validity is that like they converge towards each other in terms of measuring the item in a similar way on the same group. Same concept, different measures, same group. Don't have to worry about the calculation at this point. If it doesn't correlate, who's to blame? Convergent measures support each other. Just think about it conceptually. We have discriminant validity when it doesn't correlate with the concepts. We would actually use that if we wanted to measure two different distinct concepts for validity. So if you both have different reasons to wear black shirts, that might be something we can measure. If you have the same reason, we want convergent validity, for example. I'm sure you guys did not plan to wear black shirts at the same time. Or maybe you did. So calculate correlation should be low, shows that the measure is distinct. So a correlation is how things move with each other and how strong or weak the relationship is. When we discriminate on validity, you wouldn't want that. You'd want to measure it differently. So for example, does it measure? These different? No, they're not. Okay. So for example, we could look at like birth order, gender, race, socioeconomic status, shows a measure as distinct. We're discriminating on that. Does a measure correlate with future outcomes? This is criterion validity or predictive validity. So if you're really intelligent, are you going to do well in college? It's convergent. Like we're trying to predict something now. We're saying we measure your intelligence here. How are you going to perform with your intelligence over here in school? That's your convergent validity. Also criterion validity. So let's walk through criterion validity a little bit more with like a visual. See my screen, right, Janessa? Good.
Yep.
Okay. Hang on. I want to make this smaller. So you're all going here, and you probably want to use that degree when you finish, probably. Images. It's a pretty good one. This one's probably better. Oh, that one's better. You see that? Let me see if I find the other one over here. Do you guys see this right here? This picture right there. No. Accreditation is the academic and professional weight of your college degree. That's why it matters in the real world. In 1895, the Department of Education broke up the United States into 6 different accrediting bodies: Northwestern, Southern, North Central, Middle States, New England states. That's criterion validity. Why do you have to take electives? Why do you have to take general education requirements? Why do you have to take a math class so that you graduate with an associate's degree? Because every school to have the academic and professional weight in the real world for it to count does similar things. It's consistent. So you get a degree from DuPage, it's like you got an associate's degree in California, criterion validity. The Western Association of Colleges and Schools, their associate's degrees are very similar to yours. You study similar things, you have similar criteria. That's your criterion validity.
California has its own thing.
Yeah, and Hawaii. You're in the largest one that has 19 states.
Forgot Hawaii.
But Stanford, Harvard, like they're regionally accredited too. They're just good at branding. The academic weight is your regional accreditation. That's the gold standard. There's other types of accreditation like programmatic, like you're studying to be a nurse, CCNE, NLN, Board of Registered Nursing. That's great. But in terms of just criterion validity, it's all regional. So whatever region you're in, it counts on all the other 5 regions. That's why it works in the country. That's criterion validity. Or sometimes we use it at like predictive validity. Hopefully that example is making sense to you guys. It might not work because they have different criterion. My wife has a bachelor's degree from Venezuela. It's a 3-year degree. It's about 2 years here if you bring the credits in, which is annoying. But then again, she didn't go to school for 4 years. She went for 3. So does the measure correlate with important future outcomes, especially behavioral? Just your achievement, years of school completed. Measure the concept, measure behavioral outcomes. Should be a correlation. This is predictive validity. Again, does intelligence drive your achievement in school, for example? Should be a good correlation. Don't worry about the numbers yet. Ultimately, predictive validity is the trump card. Can I predict what you're going to do from one test to something else that's related, like achievement? Then I probably have pretty good validity. If criterion is measured at the same time, you have concurrent validity. Does it have the same criteria to measure, like the accreditation? Make sense? I'm not totally losing you guys. Good. So validity, face validity starting point, it's meaningless. It's just like logic. Construct content validity, measure is broadly connected. Construct convergent, it agrees with other measures. Subjective well-being, happiness, like ways you might measure those things so they all lead to the same road. Discriminant validity, we're looking at 2 things kind of separately. and we're measuring them apart from each other. We're discriminating on the two different measurements. Criterion validity, that's that regional accreditation in many different states. Predictive validity, because it does predict future outcomes. And concurrent validity, measures related to current outcome states of importance. Just good predictability, like diagnosing mental illness. Makes sense so far? Ish. Why do we do this? We want to eliminate bias, limit reactivity, item analysis, broad coverage, and limit influence of other variables. Cage fight, reliability versus validity, both required for a good measure. Reliable does not mean valid. You can be very consistent and get the same results. You can have a completely worthless measure. If it's unreliable, you cannot determine the validity because you're getting different results every test. Both established by examining correlations, reliability, correlations with the same measure, validity, correlations to other measures, things that are measured similarly. Both improved by piloting. A pilot's like you do a study with a small group, you get feedback, and you do that with a bigger group. And then item analysis. Did I measure the things correctly? Did I operationalize the variable correctly? Did I have the different criteria? Make sense? On examples? We'll skip that. So validity. Does the measure seem valid? Content validity, does it cover the whole range? Criteria and validity, measure is useful. So like, is it measuring the thing correctly for validity? We got one more review slide and then we'll do some worksheets on chapter 3. All right, chapter. Does that help kind of fill in like gaps, so to speak? Okay, I think our last one is on types of variables, I'm pretty sure.
Thing from last class, right? This like slideshow here from last class, like content.
This is from a different stats class, these last 3 lectures,
But this, but the material,
but the material is
same from last class.
the class probably before. No, you mean like in the summer?
No,
Our
last
last
week,
Yeah,
last week.
yeah. I'm basically like recapping on the first like 2 classes, like what variables are, what independent variables are. I'm just trying to give you like a sense because I actually added these last section because I was finding that people were missing stuff about what things were. So please tell me this is right. Oh, great. Yeah, then we have a review built in, even better. Okay. Play. So let's just recap on chapter 3. Central tendency. Measures tend to be towards the central distribution. You have a mean, median, mode. Population size is n, sample size is n. Calculations are largely the same. Talked about that about an hour ago. Why might central tendency be important in the real world or psychology? Why is that important? Mean, median, mode. Average. Ways things are repeating. Hector, yeah. Climate change, sure. Yeah, that could be a reason you could use central tendency. You look for the average and see if the average changes. Yeah, climate change. You could also have your practical application. Your 2021 median pay for nurses, 77,600 per year. Knowing the average of what everyone else is making in the area, so you can negotiate salary. You could absolutely use that in the real world. I'm getting that from going here. Janessa, if you just go nursing plus department. That's where I got that from. So you can see that.
Okay.
So like you can absolutely use that in the real world. Slide. So central tendency does matter. For the mode thing, and my student that did the recording on people exiting gangs, did the research on that. That could be helpful in terms of social programs. I think we already saw that. And I feel like this is, yeah. Let's do the highlights. Population mean, sample mean. Same thing, sum of the values divided by the total number of scores. Mean and a sample size weight of each mean. I feel like it's pretty much what we went over.
I don't remember going over this last week, last time.
Yeah, we went over this. We did the weighted mean. Measure the central tendency, so median. We did. We totally watched the video. I'm positive.
About what?
I don't remember this at all.
We did it.
We did it.
Like talking about they use like average.
We did it. No, I'm joking.
Yeah, that's the same stuff.
The weighted average, that's what they said,
Dude
instead
was
of
like,
median,
like,
it's
yeah.
average.
No, 'cause, like from what I remember vividly is the like for example, the ungrouped variables, the group variables, the
We did that too. We were here
top
for 4 hours.
down,
Yeah.
Like that, like that's what I'm talking about.
Yeah, we did that. We
Remember,
just,
dude, he was like writing on a whiteboard and like see his hands. like, in the
Oh
video.
yeah, that.
that's what that
But we're
was.
gonna go over like the worksheets.
We're doing worksheets right now.
No, the same content of the worksheets that we did last week, right?
Uh-huh. We're doing that right now.
No.
Like relative frequency and all that stuff.
Yeah, well, I have stuff built in. Let's see. So I
Now
think
we're doing chapter.
so. We just did that one. I think this is what we want to do right here from last week. Yeah, so let's do 9-8. And you do the first half. Let's do that second worksheet, the second half of that worksheet, summarize central tendency. Let's do that in small groups or as individuals. Janessa, that's in student resources, in-class activities. And then it's the date of 9-8 if you want to watch the path here. And then
Sorry.
I will be happy to walk you through the answers, but I'll give you a little time to work on the worksheet.
Okay.
So if I just walk you through, if I walk you through the answers right away, like you won't learn anything. So we're going to in-class activities right here.
Yep.
And then scroll down till you see some of that you can't see. That's on purpose. Homework 9-8.
Okay.
And you're gonna click on that. And then we did the first half, our last class. We're looking for chapter 3. So chapter 2 we already did. No one handed that in yet because I didn't make that due. And then you're gonna go down to summarizing central tendency. And then you're gonna do chapter 3.
Okay.
And it's like a couple of, yeah, it's a couple of pages. And then I can come around and help you as you go through it and or go over the answers, but I'll give you like a solid 10 or 15 to kind of work in groups and ask me questions and or take a bio break if you need to. And then we'll walk through the answers.
What page did you say we were working on?
This is in class assignments and this is the date of 9/8/22.
No,
I can
mean
show you, what was that?
I have it open. What does it look like though, that where we're starting at to work? Oh, right here, I
Oh.
see.
Chapter 3.
Okay. Sure.
Summarize it like right there, like that.
All right.
Now, if you'd like to work with your colleagues, I can move you over by some of them.
Oh my dear God.
You want to work in a small group?
Sure.
Who would like to work? Janessa. Anybody?
If not, I'm totally cool too.
You guys want to? Ariel, Marina, Janessa, I think you all know each other. So you can.
Oh, hello.
Hi.
Okay. So we're just starting at 1, right? Looking for the mean, median, and mode.
Yeah.
Right, yeah.
When you say state the following values instead of data, which set of numbers do you want?
Okay, so what are we?
All of them.
I'm sorry if I'm not much help.
No, you're fine. I'm actually gonna open Excel and try to do it the way he showed us how to do it.
You can ask me questions too.
So
about
would it
anything
be
you're looking
this,
at,
the
okay?
one that we just talked about, like this one, like mean?
Yeah.
This one?
Yeah, so the mean, that's gonna
So-
be add them all together, divide by the total number you have.
Okay.
Right, so then we add all of them?
Yep, and then you have 1, 2, 3, 4, 5, 6, so you have 12.
Mhm.
So you add all of them, that divide by 12, that'd be your mean.
Okay. Okay, got it.
And then your median would be n plus 1 divided by 2. So n would be 12, you have 12 numbers,
Mhm.
plus 1 would be 13 divided by 2.
Okay, okay.
Makes
Alright.
sense.
So then it's gonna be 4 plus 9 plus 12.
I can put the formulas back on the board if that would help.
Yeah,
Would you like that? Would that be helpful?
so it's 96.
I'll come help you in a second.
2, 4, 5, 6 divided by 12. So our mean is going to be 8.
Okay, how did you get that?
So
Like,
he said to add all the
So here's-
different,
so here's the
so
mean.
we're adding all
Here's
the
your mean.
different weights.
And then
Yeah.
So we're just adding all of the weights.
Your
So
median.
4 plus 9, 12, 6, 10,
okay, so
8,
you're adding all
So
of those.
the median is where half of the scores fall above and below.
Okay.
So I added all of them and then divided them by 12, right, for the mean?
That sounds
Yep.
right.
Yeah, that's right.
Okay.
Yeah.
That sounds
Yeah.
right. Sorry, my
Okay.
dyslexia is trying to kill me,
Oh,
and I
that's okay.
am not, like, I understand it, just I can't see it.
Okay.
No, just, no, never, never mind. Okay.
I
Um,
got the median, by the way, and it's 8.
it's,
Yeah.
yeah, okay, yeah,
And I literally just did that by typing the 2 rows of numbers into Excel. And then I typed equal median and then did the, I don't even know what it is, this one. And then I highlighted them and I did this one and then I pressed enter and then it gave me 8.
Nice.
if that makes sense.
Median is position.
Yeah, I know,
So you're looking for the position of,
Never mind.
of the list of the numbers.
No, you, it was-
So that's like that told you 2.5, like it tells you like where it is, like with the roots, it just,
so for. the-
yeah, I think it's 8
So
also.
for the medium.
Yeah,
Find the medium for the following.
and the,
so is the mean.
the mode is 8,
So
right?
the medium, we need to add like how many, so it's gonna be 12. So it's gonna
Wait, where are we at now?
The medium.
The median?
Mhm.
Okay. The mode is 8, right? Because
Yeah, so, no, the mean is 8.
the mean is 8. I think the mode is also 8, right? That's where you see which number is repeating the most. And that would be 8 because it's repeating 3 times. Value that occurs most often. It's on the 13th slide in chapter 3, PowerPoints.
The left and the right, then that would, that's your median.
What am I looking
So did
for?
we get 8 for all of them?
I think so.
Okay.
You do the formula.
The mean. Some of the scores, total number, okay.
It is. Remember, so what is the
Um,
shape of-
I have a question.
How did we get the mode? Like the
So
median?
for the medium, we're gonna do 12, right? For the medium, it's gonna be 12, because we hit, that's how many we should have.
Yeah,
And
so it's the sum of all of them divided by 12.
For the medium,
No, for the median, it's the midpoint, so that's that formula right there.
so it's gonna be 12 plus 1 divided by 2, or where's the 2 coming from?
Yeah, that's right in
Okay.
the center, yeah. that's
So
right.
then it's gonna be 6.5.
So 13, wait,
12 plus
Yeah, that's
1
right. That's right, that makes sense.
plus
Yeah, but that's
6,
odd, you gotta do the even one. So the n is even.
oh,
The median
okay.
is a 0.5 position.
So
So it
then,
would be 12 plus 6 divided by 2.
so then leave it at 12?
So the median, so how many scores do you have? You have a total of
12
12, so 12 plus
plus 1 is
One is
13, divided by 2 is
2 is
16.
5. So the median is in between. So it's that, so see how it's at 2.5? So it's right in between, so 6.5. So what's the sixth number, what's the seventh number? Add those two together, divide by 2.
Okay, hold
Does
on.
that make sense?
No, so at the 6,
No, that's your position.
Your
So
position
you're,
is,
so 6.5, so remember the median's like, we're going like this.
Right.
So it's gonna be your sixth number plus your seventh number
right?
divided by 2. So in the list of the numbers.
yeah, but does the list go this way or does it go this way?
It's from lowest to highest. You should, for this one, you should be getting, it's 8.
That's what I, okay,
But I want you to be able to get there the correct way with the math.
yeah,
Right, so how
So-
did you get there?
so you have to reorder it, right?
Yeah.
Got it.
Which you can do in Excel. All you have to do is put the numbers in Excel and then just sort.
Yeah,
each
that's what I
heading,
did.
Lowest to highest.
Oh, that's what you did, okay.
And then it'll show you, it'll sort if you don't want to do it by hand. I can show that
Got
on
it.
Excel if you want, but if you literally have the numbers in there, you just click like filter, sort, you can do lowest to highest and it'll move them
Okay,
and then you can see it.
And
okay,
then
okay,
just-
thank you.
Okay.
So see, like, well, they, so that was even, so they did 99, so it's 2.5, so 2, that's 66.5, so that's like right between, so.
Yeah.
We don't know which one it is, we don't know if it's the 66 or the 44, so we took the 66 and the 44 because
It has to be in between the two.
it has to be in between the two, so it can't be this one. You're right. It can't be that one, it's somewhere here, so we're gonna add the 2 right in the center, 2.5. That's how they got that.
Okay,
Oh, okay.
so now we're on what, question 2? Or are we still on question 1?
Okay,
And then
so
your mode is the number of the thing that repeats.
Yeah, that one,
Yeah, that one.
that one was easy.
So are there all 8?
Yes.
Yeah.
Okay.
Yeah, they're all late.
But I want you to know how to get there. Yeah. they're
Yeah.
all eight.
Okay.
I'll come over in a
So
second.
what's
Alright.
the shape of this
And then
distribution?
move over there.
So it's, I believe it's that one that was like right in the middle like he did. Remember how there was the positive, the negative, and the one in the middle, but I don't remember what those are
Yeah.
called.
Mean, median,
I don't
and
remember
mode
either.
are
Yeah.
all
So
on
What
top.
did he, it started with an S, like the,
It starts with an
um,
S?
I thought it, like the, what he called the,
If your mean, median, and your mode are not all on top of each other.
oh, I can't think of it. I literally wrote it down, but I didn't put the name of it.
We know it's a normal distribution because the central tendency is what changes that bell curve into something else. So because they're all the same, it's symmetrical. So you say symmetrical or normal.
Yeah, there you go. It's symmetrical. That's what I meant.
Metric, okay.
Yeah, where it's completely
Here, let me show
even
you.
on both sides of the median.
Thank you, though.
Yep.
Okay, so it's symmetrical. Wait. Okay, yeah.
You see that
Oh,
right there?
yeah, but I
Like I get that.
Okay.
So
Yeah.
your median, your median, and your mode
Data.
are the symmetrical, they were all 8.
Oh,
So
okay,
that's why it's symmetrical and normal, because if they were,
because they're all the,
Because it's up like this.
if they
and
were
it's
over.
big.
if they were
That's
over
what I say
here,
like this.
Yeah.
Yep.
Positive or
Yeah.
negative skew, you say a positive or negative skew.
it's too late
If
to
they
be
were
doing
like
this.
that.
See, I told you it started with an S. It was a skew.
Or symmetrical.
Okay, so to the 8, we're adding the 10.
No, you don't have to add anything. Your central distribution, your mean, your median, and your mode are all
Seeing whether the
8.
mean
You have 8
increases,
that
decreases,
repeats
or
like
has no
3
change in
times.
each of the
You
following
have 8 in
scenarios.
terms of your midpoint,
But
and then you have 8 as your
13th
average, so
value
because those
of
are
10.
all the central tendency and what the numbers are, that makes it a bell-shaped curve. That makes it symmetrical
Hang on,
because
guys.
it's
I got
basically
the median.
saying
It's
all
still
the
8.
numbers to the left and the
What?
right.
The 10 is added to the, hang on, state whether the mean,
Because of what your average or your central tendency or your median or your mode is. If
so
they
for
vary,
the, just so you guys know, for A, the
positive.
median will
negative,
not change, because I just did it again on Excel and it stayed the same.
So your
wait, what?
So we know the So on A, it says which one of them would change. Oh, state whether the mean would change. Oh, wait, never mind.
It's asking
it was-
whether the mean would increase, decrease, or
increase, decrease.
I was looking at.
would it, the mean increase if it's
Your median and then your mode to the
I
right.
don't know this.
if it's the highest number?
Distribution normal, just like,
I don't know.
Like, I get what you're saying, but I don't get.
I don't know the question.
Hold on.
what? Let me see.
A
I'm gonna go over, I'm
13th
just-
value of
The 13th
4?
value of 10 is added to the data.
I would guess a value of 8
Yeah,
is
so-
removed
Yeah,
would
so a 13th value of 10
probably,
is added to your 12. Because there's 12 in there.
Yeah.
I would guess that
So
So
wouldn't
you're assuming
change
there's a
it.
13 as
And
part of
it's
that.
10, so that I redo the whole thing with the 10, right?
Well, I don't know.
I don't, yeah, all of.
So.
A 13, yeah,
Percent,
yep.
yeah.
So all those
I'm
numbers.
sorry,
and
I'm
then your
like no
13th
help right
values-
now.
Yep, that's it.
Do like, do everything again.
Yeah, so, okay, remember when you added up the total of all the numbers? What was that total?
I think he's next. And then
The
you.
total of all the numbers.
And then you.
Yeah,
I'm sorry.
that
to
he
go on.
added up.
I think, hold
What
on.
was the total? Hang on,
Do you remember what the total was of all 12 numbers?
Of all 12 numbers,
Did you write it down or no?
yes, I.
Yeah, so you- I'm asking you to do,
55.
like, whatever
55.
Okay, so add 10 to that
the original data.
and then divide it by 13.
Sorry, it's 96. Okay, hold on.
Okay, and then divide it by 13.
So add 10 to it and divide it by 13.
Yes.
Okay, so.
8.15.
So this.
8.15.
So it changes it a little, so it would increase it. It would increase the mean because the regular mean is 8.
Okay.
So then it would increase.
Yes, increase. I would, and if you want to, we could put 0.5 to sound real smart.
Scenarios.
Increase by 0.5. Okay, now, did you guys, do you know how I did that?
So then 96 plus 4.
No. So remember the mean in the beginning, you added up all the numbers and then you divided by 12 because there was only 12
Yeah,
values.
but now you
So
add the
then-
10 to that number and divide it by 13.
Yes, there you go. So you just had to add the 10 to it again and then divide by 13 because it added another value.
Yeah.
So it gave us that 8.5. So now with
Wait,
13,
hold on, we didn't do that.
96 plus 10
96 plus 10.
divided by 13 is, yeah, it's like, it's 90. Wait, hold on, I did it wrong.
8.15.
96 plus 10. divided by 13. It's 8.15. So it would increase it by,
So it
what,
would
would,
increase.
wouldn't it increase by 0.5?
yeah, that's, or it would increase,
Because it was originally 8.
so it would increase 0.15, yeah.
Point. Okay.
0.15.
0.15, okay.
Yeah.
That's if he wants decimal, but, so now we're doing the same thing with
So we're doing
four.
it with 4.
Yep.
Got it.
So then we're doing 96
Plus 4
plus 4.
divided by 13.
divided by- Yep,
divided by 13.
so it'd be 7.5, so it would decrease it.
Increase, okay.
Decrease, no? B?
Yep, decrease.
You
Yep,
were on B,
decrease.
it would increase by, oh wait, no, sorry, it
No,
would decrease.
Yeah, yeah,
Decrease.
yeah.
It would decrease by
It's
1.
okay.
Right, because it's 7.
Yep, and I just put 7.54, I just rounded up because we're keeping it at 2 decimals.
Okay.
So.
Wait, is this asking like we have to tell them like the
X
total?
value
That's
of
what
every
I
score
mean.
minus the mean, so minus 8,
Okay.
and then take all those numbers and add them. You should end up with 0.
All
Okay,
right.
hang on, so now we're taking out the 8, so we take out 1, 2, 3.
From the original set.
So we were originally at 12 minus
Yes.
3.
So there's one way removing it.
So it'd be 96 minus 8 divided by 11.
Everyone minus 8.
No, because you remember there's 3 8s in there, so it would take out 3 values.
Oh, okay, so all of the 8s, got it. Okay.
Yep, so you'd have to take 12 minus 3, which is 9. So then that's when you do add up those 9 numbers minus the 8s and then divide by 9. So
Got it.
That's the order, right?
all right, it is 8. So it would,
Yeah.
it would stay the same, no change.
Same.
Yeah,
God,
that
that's
was
so
what I
weird.
got as well.
See, this is why math just kills me. Okay.
Okay, so
A
for
13 value.
And now we're on what, D?
yeah. So it would
So
be,
basically, we just got to go back to 96, because that was the total of those 12.
Yeah,
Add 8 again, and then divide by 13.
okay.
Eight.
96 plus 8
It's 8. Yep,
divided by 13.
Yeah, I don't know.
I don't know.
It stays the same.
Yeah.
it does. So no change.
Last week, you take the X value.
Okay.
Okay. So now we got to do what we did just before that, but with 12.
Yeah.
So the 11 value.
The
So it's gonna be
value-
96 minus 12,
Yep, there you go.
Yeah, I was making sure there wasn't more than 112 in there.
and then divide
You're doing this.
by,
You would divide by 11.
Value
Divide by 11, okay.
minus the mean.
And I got 7.63.
for
Hold
each
on,
one,
wait.
7.63.
And then get
Let
your
me-
sum.
Yeah, so it would decrease a little bit.
Let me try that again because I got something different.
Okay.
And then you, right?
I got 7.63, okay. So it would
Um,
decrease then.
So we just wanna, like, for example,
Now you can use the rules or you can do the math. They'll both work because let me show you the rules up here.
Oh dear God, we've been doing the math the whole time.
I think we're. Hold on.
I think we're doing it right.
See that?
I just wanna see what
So you can either do it by hand and those will be correct, or you can use the rules of what I'm asking you to do and you'll know the answer whether it increases or decreases.
But you wouldn't be mad if I just did it by hand.
No,
Okay, I'm gonna do it by hand.
but those rules will apply.
Okay,
I can't see those rules, guys. So
and
otherwise
so
I would
it's
do it.
on chapters, the PowerPoint for chapter 3, and it's on slide, let me find it.
Characteristics of the mean. I can probably tell you. what slide.
Characteristic of
You
the,
want the number slide?
yeah,
I
yes,
got it. I found it.
you found it, okay,
15.
15,
15.
okay, cool, cool.
And I'll probably.
Oh, that made it so much easier. Okay, hold up, guys. Let me help you out. Here. Let me move this over. I can't really see you guys, just so you know. So sorry. All right, so the value of 7 is removed from the data.
Oh, no, and square the square.
Okay, so look, so
X.
part 3.
Value minus the mean, get your number, square that,
Yeah.
and then add all those to each other.
So
You should be around 116. But do the math.
Around one.
Might be 120, might be 130.
Okay, so what I got for F, if you look at the rule part 3, the value of 7 is removed from the data.
The value.
So if you delete a score below the mean will increase. So
Yeah.
we know it will increase. So we don't, I mean, we're doing the extra work with the decimals, so we can just put increase.
Yeah, I did the math and it,
Increase?
yeah, I did the math too, and it's like 8.09, so like
Yeah.
1,
Minus
Mhm.
0.
So it would increase.
it would increase. Not a lot, but it would increase, which is all we need to know.
9
Okay, state the new value of the mean in each of the following scenarios. Each value is multiplied by 4.
Wait, what?
So
I'm
now we
wrong.
have to go back and create new values.
So if each value is multiplied by 4, you can just multiply the mean by 4.
Oh, okay,
Oh, okay.
thank you.
96.
I thought maybe that was it, and I'm like, no, there's gotta be more to
No,
it.
no, it's stats. It's pretty straightforward.
It's so, okay.
Okay, so
So it'd be
somewhere for
384.
maybe 32.
Wait, what?
No,
If
no,
you-
no,
if
we
you
can,
do
we can
every-
take,
if-
we
if
can take
you-
the mean and then just multiply it by 4.
Right.
Because you get the same answer.
8 times 4, no.
No, you can take the-
okay,
the
okay.
Because the mean's the
total.
average.
You can take the
So
total.
you can take them all and you divide them, you
Wait.
still get there. But if you want to take a shortcut, you just multiply the mean.
So it'd be 30, it would be 32.
Yeah, so it would be 32.
Yeah.
8 by
4 is 32.
Oh, I'm so sorry. I
Because
did it
if
wrong.
you multiply them all by 4 and divide them by 12, you'd still get 32.
Oh, okay.
Okay.
Cool, and then each value is divided by 2.
What?
So then,
So you would just have to take 32 divided by 2.
so all of the numbers divided by 2.
Nope, nope, so just
So
how we
you
did
could also
each
take the
value
mean
multiplied by 4.
And divide the mean by 2,
Uh,
Divide the mean, so it'd be
because
4.
it's, because all the values
be
are in
4,
half, so
right?
it's gonna cut the mean in half.
Yes, there we go.
Oh, okay, so that would be 4.
Yeah.
Yeah.
And then, if you added 8, that would be what, 16?
16.
Cool. I'm making,
Ooh, we did
I want to make sure I'm doing this right.
Yeah.
No, that's totally fine. I'm excited that I'm getting it. I
And
hate when
then
I don't get something.
4 subtracted from each value, so
So it would be 4,
Yeah,
right?
yep,
it'd be, okay.
yep. So every time it says each value, just literally think of mean.
The mean, right?
mean.
Yeah,
Yep.
okay.
Just don't even worry about the each value. Oh dear God, no, I don't know this part.
What-
Mean.
What is the
Keep
number
scrolling,
5 part?
guys. Keep scrolling.
What's
Oh,
number 5?
skip 5?
So 8 times 4, 32.
Are we skipping 5? No.
Are we, what are we doing for number 5?
Yeah.
5 is actually the math for number 4,
Oh.
Oh,
so you're fine.
Oh,
oh, so,
I'm
so we don't do
confused.
anything with 5.
Cool. Okay, subtract the
So the
mean from
next thing
each
when they're
score.
measure, mean, median, mode, central tendency, which one would make the most sense? And why?
Wait, do you want us to do 6, 7, and 8?
6 and 7. There shouldn't be, well, there's technically an 8 of it.
Oh, okay, sorry. I just read it wrong then.
There's 6 and 7.
Yeah.
And then the next thing you're gonna do is you're gonna say in these scenarios, I would use the mean, the mode, and I can pull those rules up too. So you're gonna say, in these like scenarios, this is how I would measure central tendency and why, but I can pull those back up for you if you want the guide once you get to that point.
Okay.
And then I'll show you guys the answers after you get there, and you can check them.
Okay.
So if you get all the way to the bottom with the X minus M guys, keep scrolling, there's scenarios.
So for number, what do we say for number 6?
I don't think we've gotten there yet.
Oh, okay.
no, we're sitting. Okay, so subtract the mean from each score. What score? The 32, 4, 16, and 4?
Yeah, I think so.
So, wait, what?
Is that what he means?
Subtract the mean from each score. What is
Hang on, maybe it's 4.
What?
Hang on, I'm gonna try.
So he wants us to subtract 8 from like,
from all of that? From each?
I have no idea.
Yeah, that's what changes. You'll see like when they're all having each other.
When he
Because
comes
then
back,
it would be like negative.
when he comes back, we can ask him.
They're not.
Um,
Saying they're just like the mode of the right, either more than median.
Do you guys-
It's like 96.
That wouldn't make sense though.
That would not.
Yeah, number 1. The median.
I don't know.
When he comes back, we'll ask him because I have no idea.
I don't think it's asking them.
So this.
Would it be?
So I'm gonna put the rules up on the board for you.
Yeah, so like, depending on this.
Mean, median, and mode. When you,
Yeah, I don't know.
yes, no, it's fine.
So for this one, subtract the mean from each score, where I subtract the 8 from all the scores.
From the original set of data.
So 8 is the mean.
Yeah. So scroll back up. You see these right here?
Subtract 8 from all of these.
Yeah, so 4 minus 8, 9, yeah, and then.
Oh, okay.
And then take all the values that you get and add them together. Your answer should probably be roughly around 0.
Okay, I see what you mean.
And then the next one, you're gonna do X minus M, and you're gonna square them, and then you're gonna add all the squares together. You
Wait,
should get around 160.
wait.
Yes.
Wait, what are we doing for number 6?
Subtract the mean from every score. So just X minus M, like, so scroll up to here. So it's gonna be 4 minus 8, 9 minus 8, 12, and you're gonna take every single square you get from that difference and add them together, and you should get roughly about 0. Because you subtract the mean from every score and then add those sums up, you should get 0. And then the next one is just the same thing, but taking all the squares and adding them together. Just to the first one, I'll come back.
Okay. So we do subtract 8 from each weight, from each difference in weight. So, okay, so for example, it's gonna be, no, it's gonna be 4, no, maybe 8 minus 4.
So here they are.
Would it be 8 minus 4 or 4 minus 8?
I think it's 4 minus 8, because you're subtracting 8 from them.
So it'd be -4 then, right?
So it's gonna
Yeah,
be
it'd be -4, and then 1, 4,
What if it's nominal data, like
-2,
use
2,
the median for ordinal scale data
-3,
and
-1,
distributions of data.
7,
Give it your best shot.
and -4, because you don't have to worry about the other 8s.
Number one, and how we got.
So -4 plus 1 plus 4 plus.
Sorry, just like three row stats.
No.
Yeah, that's better.
What letter do you need?
Do you need?
For number one, try to find whether it's median or mode.
okay, like.
It's
for
0.
example, this is what
It's
it
0.
It was 0.
It was 0.
The answer, it is
Okay,
0.
sorry, I was
Yeah.
still doing the math.
No,
No, you're fine. You're totally fine.
so it was 0,
It's
but
exactly-
then that's
So what is the sum of the difference? 0 is the sum of the difference, I guess.
what is the sum?
It would just be 0, wouldn't it?
That's what I was.
On which
Yeah, I'm
one?
gonna-
Yeah, it would be,
Your rationale.
wait, subtract the mean from each score and square each difference. Isn't it just 0 then?
Yeah.
It
I
doesn't
believe-
change because it's 0.
Yeah.
Right?
Yep. It's
I
0.
have a question. I don't know, I'm so lost with this.
Number 7?
No,
So
for
ordinal is
number
just like a
6,
rank
like
or order?
what was the sum
Interval
of the difference?
Has equal spaces and no absolute 0.
It's literally
Ratio has a 0.
Wasn't it?
when you look it up on the PowerPoint on slide 17,
Mhm.
it says sum of difference of scores means equals 0. So I literally think the answer is just 0.
Okay, cool. And then number 7 would also be 0.
Subtract the mean from each score and square each different. What is the sum?
Or maybe it wouldn't be, no, because then you'd have to, nope, it wouldn't, because you'd have to
This is our
take like -4 and square it, which would be 16. Right?
Yeah. Well,
No, subtract the mean from each.
Because it-
still be square each difference.
Right? Because
square each difference. Yeah.
-4 times -4 is 16. That'd be 1,
Wait,
16.
-4 plus -4?
It's -4 times -4 because he wants us to square it.
Oh,
That'd be 4, so we won't have any negative numbers. That'd be 4.
No.
That'd be 0. That'd be 0.
Yeah.
That'd be 9. I didn't get any further than that. Hold on. I got up to the
Yeah.
-4. So that'd
What?
be 1.
What is going on?
9, 10,
Always
11,
what do you
12, 13, 14, 15, 47. So that'd be 49.
What do you mean the chart? Like the Word document?
That'd be -4.
So the
Which would be
worksheet, you
16.
should have
and 0, which would be 0. So does that mean that after you square them, you have to add them all up,
Um,
right?
I believe.
Okay, let me do that math really quick because I have them all written out.
You have this right here, right? It's like the second half of the worksheet.
Sorry, my worksheet is all messed up.
I finished. And I-
4 plus 9 plus 1 plus
I have a question.
49 plus 16. I got 116 total, or sorry, 232.
Picture with your phone and upload it along with the other.
232.
I don't know. Hold on, let me redo the math.
Okay, I'll help you too.
16
Yeah, and just make sure you upload, so I am gonna check.
plus
We can upload both, right?
Yeah.
49 plus 1 plus 9
I think we're about ready to go over answers.
plus 2.
I'm gonna help Marina than you, because I saw her hand first. I don't know who raised her. hand.
So for number 7, subtract the mean and each score and square each difference. So like I already subtracted, which is
Does that mean that we square those and then we add
Yeah.
them together once they're squared?
Yeah, so what you can do is you can do, so if you go into Excel,
Have you seen mine?
so put your first one here.
Well, I'm not.
Yep, and type equals D2,
D2, okay,
and then shift 6 button,
shift 6,
and then 2,
and then 2.
enter. Now, highlight all of those
It's like I really get off.
and click fill down. Oh, did they already do it? Yeah, yeah,
What was the answer?
And then do
but,
I,
well, don't do the 0, just do, make sure you're doing, yeah, now sum all these together. So highlight all those and then sum.
so 116.
116, okay.
Do you see how awesome Excel is? That like
Yeah.
saved you a bunch of
Do you
time.
want to see the formula?
Okay, you
Are you
got
talking to me? Yeah, let me see it real quick.
Yeah, here, let me
Cause
show
I
you.
was trying to type it in on the Excel and I couldn't.
Yeah, I haven't
Yeah.
downloaded it yet either.
Oh, wait, you don't have it in Excel?
No, I do have it in Excel right now, but I was trying to figure out what he was doing. I got
Oh,
the
okay. Here, let me
13.
see my screen.
I just want you to draw.
No, because it has those, it has that thing,
So like, take a
Oh,
picture of that.
the anti thing. It's totally fine. Can you, do you remember how he said it?
yeah, wait, can you see
Equals-
the screen?
Approximations.
So I can,
No, I can't, because your screen has a privacy screen on it. Those
No,
computer
like
screens have a
the-
privacy screen.
the slide,
Oh,
do you see me moving?
no.
Do you see any letters?
Oh, yes, 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 yes. I'm so sorry. Yes, I see it. I see it.
Okay,
got it.
so he did, on the next column, he did equals.
Yep.
And then, so the number, like, which was the negative, where the negative is. So it was like, it was -4,
Before you do the math, Nikki, it doesn't,
but
they
he,
both work.
Yeah, it's the row in the thing. I got that.
I don't know how to, and then the little caret signal,
Okay, got that.
yeah, and then 2.
Those
Two,
those
and
will
then-
work. Or you can do it by hand.
Oh, wait, I see.
And then the answer is 16.
So if you add a score above the mean, I think that's the first one, it means it's gonna increase.
Do you see it?
Yeah. I
So
don't
it's
know
basically
why.
this caret 2.
Okay. It's not working. Hang on.
Hold on. Can I?
Sure. What do you think?
The positive skew,
Oh.
Oh,
negative skew.
does he have an Excel here?
Fine.
Yeah, go down. Right there.
You want
Okay.
Excel, you want this, you want that.
Perfect.
Okay, so basically, this is what we have, right? So we have 4, 9, 12, 6, whatever, right? All of them,
Mhm.
like that,
That was
right?
my comment about the class.
And then we did the negative, so it was
For me,
gonna
right?
be
Okay.
equals
Okay.
this minus the 8, right? Because we did subtract the mean. So
Yeah.
it's -4, right? Okay, so to get the answer for number 7, it was equals, so it's this one,
Mhm.
there's that one, and then the shift 6 to come up with the little caret.
Mhm.
You know how it's in number 6?
Yeah.
And then 2, because it's square 2,
Yeah.
and then 16.
Got it.
Yeah.
Perfect. Okay. Thank you.
Yeah. And then like obviously we just drag it down. Oh wait, there's no negative for this one. So it was this was 9 minus 8. And then
So when we're done, can we?
so this one,
Yeah, but I'm gonna go over the answers.
and then we just add all of this, and it was 116.
Give you, because in terms of learning, if I just like tell you the answers, it's not gonna.
I feel like I took the long way and I did it all by hand.
But if I.
Oh.
I wrote out the, like, what they
Or just start to make. it a little
originally
more
were when
sense.
you subtracted them here and here. And then I just squared them. So like -4 squared is 16, 1 squared is 1. And then I took all these numbers and I added them together and got 116.
Oh, there you go.
But if
Yeah.
you don't know how to look.
I mean,
stuff
if
up or
you-
what
I
to
don't know
look
if you
at,
can see
hand.
that, but
No, yeah, I saw it because I have mine written down too, and that's how I was doing
yeah,
it.
I did
Yeah.
mine by hand because 1, I don't have Excel on my laptop yet. And 2, I'm not smart enough to use it right now. My brain is working at like 48%. So,
Hey, I've been up since 5:30. I totally understand.
oh God,
P-A-Y-A-S-O.
I've been up since like 6.
Yeah, it's
So the
sucks, dude.
answer for number 7 is 116.
But then what do we know about the solution?
What?
The next part, the answer.
It
Oh.
has changed. No, I'm joking.
I would totally put that though.
I know, I would too. Be like, is this acceptable? So is that,
Once you get to 116, remember, scroll down to scenarios. Leave a blank page with every more scenarios.
But for number 7,
Number 7
what do you know about the solution?
Like, what are we?
is the lowest possible number you can get. That's the lowest possible number that you can get.
So that's what we know. What do you mean? How is 116?
This is my location. Yeah, it's the lowest possible. It's the lowest possible. It's this answer right here from the slide. Actually, it's right. Somewhere. The sum of the square differences. This produces the smallest possible number greater than 0. The sum of the squares produces the lowest possible number greater than 0. Because you do x minus m without squaring, it is 0. If you add them together. If you square them, that's the lowest possible number you can get. That's what they want you to know.
But the number seems so big.
You
116.
can't get a smaller number.
Oh, okay.
If you sum the difference between the mean.
I
and
see what you're
x,
saying.
It's
Okay.
either 0 or you square them,
Mhm.
and it's the lowest possible number you can get without it being 0.
Okay.
Now we have the next part to do.
hang on, can you
Oh.
ask him, is that just off this equation, right? That's just
Yeah.
off this equation. He's not talking in general, right?
I think he means in general, like if you square it, if it's
So
like.
116 is the lowest you can get in any.
Yeah, because
Greater
like,
than 0.
so it's the lowest possible number greater than 0 from like number 6.
Squaring.
It's from,
Okay.
because we subtracted the scores, right?
Awesome.
So it can't be 0, it has to be something. And
Something
this is the
then-
lowest it can get is
You
116.
can't get low, because
Low.
we're literally subtracting the mean from all the values and squaring it. And that's the lowest, and it's gonna be 0 without the square, and then it can't be lower than 116 because of the
Oh,
square. Like it's either gonna be 0 or 116.
There's nothing.
And
in
we're
between.
gonna use the sum of the squares later for other things and stats.
Okay.
So the sum of the squares is always the value minus all the means. And then you square all those and then you add those together for the sum
to the sum.
of all of the squares. So the sum of the squares, or SS, as it's sometimes called to abbreviate, is not a scary thing. But if you don't know what the sum of the squares is or how to get there, then it's
Then.
problematic, but you can literally take raw data. Like we can literally go right over into Excel. We have all these values. And what is our mean? So equals average. So this is our mean. 33.1. So equals
22 minus 33.
minus 1. No, it didn't work. Filling down does not work, so just gotta change the formula.
He's doing something in Excel.
So then we just change this to
The same thing we just did, the one that I showed you.
then we pull down. Down. Yeah. And then we take and we sum those. See, that's 0.
Yeah.
That's just the sum. Now we can do the sum, so we do the sum of the squares, we just take all of these values to the second power. No, that's B1. B1 is- And then if we square all these down, those are all squared. Yeah, this is not the same numbers what you guys are looking at. And then the sum of the squares would be that, and that's the lowest possible number. Now that makes sense, because these are bigger numbers.
Yeah.
It was 116 when we had numbers that were below 10. These are much bigger numbers, so that's the lowest possible value I can get is on sum of the squares.
Okay.
Okay.
All right, so now we're on what the
Number 1.
number, yeah.
We're
So
back
you
to
need
number 1 on the other page.
Approximately
Okay, so scale of measure.
slide 21, 22, and 23 are like where the answers are for that part of the worksheet, okay?
Okay.
And I have them pulled up here.
What slides is that?
21, 22, and 23
21, 22, and 23
should help you on that part of the assignment.
Okay.
should help
And then
us.
just think about what the scenarios are. Is it nominal? Is it ordinal? Is it an interval?
Okay.
And that's gonna
Okay.
tell you what you're gonna do. Because like if ordinal, then we want to use the median. If it's an interval or ratio, you want to use the mean.
Mean.
And if it's the mode for nominal.
Okay.
So just think about what each one of those are. Is it an adjective like nominal, qualitative? Is it a scale? Is it interval with no arbitrary 0? Or is it ratio with 0? But remember, both interval and ratio would be mean, median would be ordinal. So it would be nominal.
So, okay, so the second. So second would be.
So we are finishing the worksheet today, right?
Yeah.
Okay.
Yeah, we're gonna finish that worksheet today, and then depending on what, I'll probably go over, I think we can probably go over the answers in about 5 minutes or so, depending on where people are at. And then we'll probably do, probably maybe we'll start on. Or we'll get on the worksheet, so see what I have.
Okay. So in seconds, would that be,
The chapter 4 is actually.
what is that?
Energy needs
Sure.
severity.
I forgot. What second?
They're just the word sounds.
I feel like that would be interval
Interval?
Yeah, that
and
sounds.
ratio. But
So if it's in interval, then it's mean.
okay, so but would it be that or would it be skewed is what I'm wondering.
We have to, basically, we have to see if it's mean, medium, or mode.
Right. I know
Right.
skewed is in mean, so I don't think
How
it
would
is
you
skewed though,
measure
now that I'm looking at it. So it's probably mean
Okay.
for the first one.
Um,
Also?
Okay, so the preference ranking for 5 different ringtones. Hmm,
Okay, so A, it's mean, right?
which one? A?
Yeah.
A,
Yeah. I think that's what,
The preference
B,
ranking.
the preference ranking for 5 different
5 different ringtones.
ringtones. Is that ordinal? But B is an ordinal, so then it would be median.
That sounds right.
Hang on.
I think it is
Because you're like ranking it. right?
ranking,
Like
right?
1 through 5.
Right.
Okay.
And then ordinal scale is median.
Okay, what about the number of freshmen, sophomore, junior, and senior students?
Wouldn't that be ordinal as well?
Well,
I don't think,
I don't think it is.
I think it's nominal.
Oh, yes, yes.
Yeah.
Okay,
Yep.
so it would
Which
be
is
mode.
Mode.
So mode.
Okay, the number of children liking cereals containing 1 of 3 prizes.
Okay, so there's 2 different things there. So I don't know if that makes a difference. There's 2 different things being. So there probably has to be a mean.
Yeah.
Do you know what I mean? But would it,
So then,
do you think it would be mean? Do you know what I mean? Because it's talking about the number of children and then it's also talking about 1 of 3. Oh, wait, number of cereals containing 1. Yeah,
Well-
so I feel like there's children and then the prizes. The number of children liking cereals containing 1.
I think it's just counting how many children
many
like a
children,
specific
right.
prize. So I think we're just counting how many children.
Okay. Yeah, you're right.
I don't,
yeah,
maybe,
I don't, yeah.
maybe, I don't know.
No, you're totally right. I'm so
Would it be-
tired. I'm sorry. I'm like, what? I
would
got
it-
the 1 of 3 and it totally messed me up.
Would it be the mean or, wait, hold on. So if you now I'm confused. Not by this, just because my brain doesn't want to work with me.
You're fine. Number of children likes-
So wouldn't that be, because it has like.
I feel like that's a mode for
Mode.
some reason.
Or it's a nominal
Yes, because mean
scale data.
includes maybe.
Because if we go by the rules, then it would have to be a nominal.
Here's where the last part of that.
Yeah.
So no.
Here's what halfway through.
Oh.
Asking for the answer for D and we'll keep going. I'm joking.
Okay, I can hear.
Darn it. Am I really that
I
loud?
can do that before you're done, it's just you gotta understand how you got.
Yeah.
Or.
Well,
you
we're-
can finish them
I
up.
know, we're just stuck.
Right.
Yeah,
Did you say it was nominal or is it nominal?
It's
Wait, what?
like 8 of them.
Was she saying that she thought it was nominal or wasn't for a D?
Wait, so it's,
Oh, it's not quantity. Never mind. Don't even listen to me.
He's like,
Oh, the distribution.
Maybe skewed?
Okay,
see some of those? Do you have some questions?
yeah, D,
We're stuck on
on
the
D.
the last like page.
So D is mode.
Okay, so we were right then.
Yeah, it was. See? Go us. Get it.
We got it.
Okay.
Okay, now we're on E.
Are we the only ones?
No, I think there's other people working on other stuff, maybe.
Yeah. Isn't that like ratio, like for E, right? Okay.
That,
So then that
That's-
would mean
Mean.
it's mean.
Yeah.
Okay.
whoa. Good. It would help if I could type or spell. I keep spelling like everything wrong.
And you're the together first thing, right? So
So I feel like that would be mean also.
That's what I
Mean.
thought.
Because it's just like A.
right.
Yeah. The order in which participants complete an endurance task, wouldn't that be like, kind of like like B? So it'd be,
Medium.
medium,
Yeah.
okay.
Median.
The number of children in single or two parent homes.
So that would be like another,
Would that be like, like,
I feel
number,
like that's
like
like E
C?
again. Yeah.
Would it be like B or would it be like C?
Oh, wait.
No,
I was thinking it was like D.
yeah,
Oh, okay.
the children like the brain.
Oh, wait. No. Wait. Is that it? That's what I was thinking.
No, well,
Or I'm sorry, E.
Well, you said E?
Yeah.
I would say it's more like B, or not B, C. I thought it was more like C, actually.
Go mode.
The,
Yeah,
Yeah.
because we both, because we thought
Mhm.
C and D. So let's put, we'll put mode.
and then the ranking of the effectiveness of 4 types of learning exercise. Hold on, let me reread that.
the ranking, well, that's like.
I
we're
said it
ranking,
right. I
so-
didn't read it right.
Well, we're ranking, so.
I think it's medium.
My dyslexia is getting out of hand. I'm talking through it fine. I can't see it in my brain right.
So if it's scale, then that would be ordinal. So then that would be medium
Yeah.
or I.
Okay, now we're on 2.
Yeah.
Okay.
Okay, now we're on number 2.
Yeah.
In the following values for the mean and median state the likely shape of the distribution and which measures should be used to summarize it. Oh dear God, okay.
I know that sounded like straight. up,
That
I don't
one,
even know
well,
what
that one is symmetrical. Number 1, or A, I mean.
Oh, yes, you're right.
I already know that's not
Oh,
spelled right.
symmetrical, right? Because it's like
Yeah.
right in the.
Normally, this would be
Yeah.
and that's.
So hang on, I
What?
have
Just
this.
telling them,
I have these.
telling them the first half. I'll go over this with you too.
Oh, okay.
Is it not?
I think A is symmetrical.
Okay.
I'm stuck after that.
Okay, so this one would be negative.
Yeah,
So I wrote down how he looked that up on Google. I literally drew those really quick.
Okay. What was
I
that
can
one
show
called?
The sum of the mean.
The skews. He was looking at the different skews
Yeah,
measurements. So when he looked that up, hang on.
what?
Wait, are you going through over the answers already?
Because some of them are done. I'm gonna go around with you too. You guys can keep working. It's fine.
Okay.
I'm still 25.
Oh.
Still got like 15.
Hold up, guys.
You guys are like towards the end anyway.
Right.
Dang, I can't share my screen, can I?
So,
So I think some stuff got messed up. My number 6 says track the median score. What is the sum of the differences?
All right, guys, so are we ready for this?
Right.
okay, so what's, okay, ready?
So,
Yeah,
okay.
we're on B, right?
The mean, if the mean is lower and the median is higher,
Yeah.
oh wait,
This one is the mean is higher and the median is lower.
So like, you could literally go, you take this data right here.
Is this on one of the slides or no?
wait, mean, median. Okay, I got it.
No, he didn't.
No, it's not. He literally just
Googled.
Googled it.
Okay.
Here,
Okay.
let me see if I can find it.
So if the mean is lower than the median, then it has a positive direction.
Okay, so if the mean is lower than the median,
Yes,
so number C would be a positive direction.
yes.
Oh my God, I'm spelling everything wrong. It's, it's
You're
fine.
totally fine.
It's fine because we have spell check.
I wonder, can I send
So wait, would,
Oh, I have it. Okay.
would D also be positive direction?
can I? Hang on, guys. I'm
What is
gonna-
the image? What kind of format, like JPG or what?
JPEG, PNG,
What about?
no pages.
Of IMG?
IMG should be fine. No, no numbers. Like, don't use the program numbers and submit it in a numbers format. Like, numbers is the Apple version of like Excel. I cannot read numbers.
Okay, guys, I don't know if you can see his computer. I sent it in the chat. That's the
Oh, right here.
Google skew
Oh.
that he showed.
Okay.
If you go to the Zoom down at the bottom, it was right next to Excel.
Oh.
Yep, Zoom, right there. Nope, over.
That one.
Yep. Oh wait, do you guys see me?
Yeah, we can see you.
Oh, you can? Okay, move the cursor. Oh wait, you can't. Oh, I see.
Oh, wait. What did I do?
Click escape. Click escape. Just click escape again.
Here,
Oh.
I got it.
It's not doing anything.
Okay, click the red button in the top left.
Yeah, so it has to do with these slides right here.
What in the hell?
Has to do
I'm
with the
so,
rules on it.
I'm so lost.
Dude, I don't know how to use Apple either, so it's fine.
I have a
Me,
MacBook and I don't know how to use it.
Mode.
Dang, I wish I could share it with you guys, but I can't.
And mode you use for nominal.
Okay.
That easy. So you look at the scenarios.
Right.
Yeah,
So we're done with that one.
we're on number 2
Two.
now.
Mhm.
Okay, so hang on. So D, I'll just tell you the answers and then I'll try to see if he can show you guys that again.
Okay,
Okay.
I'm
So the
guessing
mean-
that
so if
because
the
of,
mean is higher, so it's median.
so I would B be negative, like a negative direct,
Where do you want to see these?
negative?
No, because they're lower than the median, so it would still be positive.
This is normal positive.
This.
Okay,
And now on E, the mean is higher than the median, so it's negative.
so frustrating.
Oh,
Not with this, just with me.
And then the last one is symmetrical again, I believe.
Wait, so what's C again?
Mode is nominal.
C,
Yeah,
Or no is
C
mean.
would be positive.
okay,
It says B, the number of
and
choices-
what's B again? I'm sorry, I keep
Oh,
asking.
wait, hold up.
It says no.
God damn it. Hang on. The mean is lower than the median. It's positive.
So that's like not, that's not like.
The number showing like.
If the mean is
Yeah,
higher,
because that would be.
yeah, it's negative, okay. So yeah, if the mean is lower than the median, it's positive.
And if the mean is higher than the median, then it's
Negative.
negative. Okay,
Yep.
so B would be negative then?
Something, right?
D would be, D
B,
would be, oh, B would be negative, yes.
and then D would be
No,
positive.
B would be positive.
So we have like.
Is it-
He has it as positive.
Oh, he has it as positive. Do we have them backwards?
I bet you I have them backwards.
It's cool. It's cool.
Just don't memorize this yet.
I have to go through everything because I take my own notes later. So that means that
So for number two,
That's why it's low.
A is
For
normal,
the types of cereal, so like.
B,
the number
oh,
of kids
he
in this
changed it.
group, versus that group, number of kids in that
So it
group.
was normal
So
and
representation
positive,
might
and then I
come
couldn't see the rest.
Does that make more sense? No.
No, it says the number of children. That's what we're looking for.
Okay, let's just tell them we're ready for the answers.
Yeah.
because I'm starting to get so, wait, do we need to do number 3 that we have to like draw a negatively skewed, positively skewed and normal distribution?
Okay,
What would
so
you
that's
do the-
literally if you Google that.
Yeah,
Right.
If you look up skew, what did I, skews of measurements in Google and go to the images, you'll see exactly what I'm talking about. It's like the third or fourth row down, you'll see like 4 different ones.
it would help if I could spell it right. Skews of measurement.
The prizes. The prizes
I
are
spelled
not-
everything
The
wrong.
kids are liking.
It's all right.
the prizes, so we're measuring the like
Again,
of the
I'm
prize.
very dyslexic and when I'm tired, it's even worse.
No, I got you. I got stuck on. the
Got
number.
it, okay.
It's what they're liking.
So then that's what we need to
So it
change.
would be a number. but
And that's
like,
what we need to
you
draw.
don't think this
Who
is
Draw
best?
who
Oh,
wants to
okay.
draw it?
I wasn't.
If you literally want to, copy and paste the picture.
We're gonna have to go through answers
Well,
pretty soon.
yeah,
Everybody's
we're
gonna
ready.
have time. Are you ready?
Yeah, we're ready.
We're ready.
Okay.
Wait.
Does she want to be over here or with you guys?
There so she can see.
See 'em?
Yeah. We'll do this. Bye.
Thanks, guys. Bye, thank you. By the way, you might see a file sent in the chat. I was trying to send him that skew picture you had done, but it didn't, we couldn't figure it out.
Oh. I'd probably have to take a picture. I think that's on the whiteboard.
It probably is. I was
Yeah,
just
it's
trying
probably on the whiteboard. Yeah, so. Okay, so my mouse will work. I'm gonna share the answers on both screens. My institution. See. That's 4 hour stats. Don't blame me. That's just the nature of it. Okay, so can you see my screen? Small, but you can see that. Now that's
Yeah.
better. Okay. All right, so here are our answers. So for number 1, mean, median, mode, all 8. You should have that. Number 2, normal distribution, it's symmetrical. Number 3 should be increase, decrease, no change, decrease. I'll scroll for you. You know what I can do, actually? It would be really cool.
Right.
More. Participants. More. Make the host. You can request you can request mouse control, and then you can scroll on the Word document if you want. I have to say yes, but you can do that
Oh, nice.
because I made you co-host. Okay, so then number 4, yeah, you gotta go. I can post these or okay. Okay, all right. Feel better. Or I can scroll for you. It's fine.
Oh, no, you're good. I was just, how do I get
So
there?
you should have a spot that says, hey, remote control, give computer. Okay, now try. Now you can scroll.
Got it. I think,
There you go.
yep. Whoa. Okay,
Isn't that awesome?
cool. Thank you.
Okay, so this makes sense, right? We got that?
Yeah.
Sum is 0, 116, smallest solution. Replacing the other value for the mean will result in a solution larger than 116. And then our next set is we have these right here. You should have mean, median, mode, mean, median, mode. Our rationale is right here.
Scroll a little bit.
Yeah,
I'm sorry, can you pull the number 7?
which one?
The one, the 160.
Up here?
Okay, yeah.
This is the smallest solution, replacing, so we took the value minus the mean and we squared it for all of them. If we go in here, I did that with these numbers, these different numbers. So this is x minus m. And then I squared those across the board. And then the smallest sum after 0 is 4770. It's the same principle here. You can't get, if you take any other value besides the mean away from x, you're going to get a larger number, whether it's above or below the mean. But if you subtract the mean, the average across the board, 116 is the lowest solution you can get after 0. These should look like that. And our rationale is right here. So interval or higher, so interval or ratio, that's going to be the mean. Ordinal is median. Nominal variables are summarized with the mode, but you might have to read the scenario again in terms of whether or not it's a mode. Because like the one that Andy and I were just talking about is like the kids liking something. They were liking this group cereal box, like Cracker Jack. It'd be the repetition of that liking because it'd have to do with like on the nominal variable of the prize. That's why it's mode. Uh, 2A, normal distribution, use the mean. Positively skewed distribution. I can put those back. You want to see those? Oh, just the note? Gotcha. Okay. I can zoom in if you want me to. Does that help scrolling, Janessa?
Mm-hmm. I'm trying to.
Yep. And then I know we're kind of right at time, but I just want to give you guys just see the answers. Number 2A.
Mhm. So 2A wouldn't be symmetrical, it would just be normal.
Because it's not nominal.
Okay.
Gotcha.
Oh.
Because it's not nominal. I don't think it's nominal for any of those scenarios, is it? No, this is just pure numbers, so it would be median. Yeah, because it's not nominal. That's why.
Okay.
And then our last answer is what you drew before. In a positively skewed distribution, the mean exceeds the median and the mode. In a negatively skewed distribution, the median and the mode exceed the mean. And in a normal distribution, they're all on the 50th percentile on top of each other. That is what influences the shape of the curve. Let's see.
That looks correct. I'm sending it, by the way.
Yeah, that's fine. Yeah, that's pretty good.
How would we, aha, there it is.
just take a picture with your phone or take a screenshot. As long as it's not like numbers or pages in terms of like file extension. JPEG, PNG, PDF, as long as I can read it, I can check your math, and when you've done, that's fine. If I can't read it, I'm gonna put a 0 in there and try to submit it so I can read it. But as long as it's a readable file. we're good. Who? Oh.
When we were on the Zoom call, that
Oh.
way I can send this to her, so.
Oh,
so that-
sure. Yeah,
um,
done. Here, can you talk to Janessa?
Yeah, okay. Hi, I need, in a second,
So
I'm gonna need your
that's the
COD
answer.
email
Feeling
because I
confident,
drew this out.
You can certainly
So
go.
that
If
we can
any
send
more
it in.
questions, kind of-
Perfect.
Okay,
You're awesome for that.
so what is your email?
EK,
But I can say a little bit past, I'm just trying to be mindful of the
EK.
time.
ER,
I'm not gonna run off, I won't stay till 10 or whatever you guys need for a few minutes.
N, as in
Just
Nancy.
to clear for you.
Aaron?
Thank you.
And I can't leave either, Skip.
Hang
Here,
on,
do you
hang
want, do you want to
Are
type
you
it in
able
the
to, hang
chat?
on, here, are you able to see the screen?
Yeah, do you want it? Okay, yeah.
There you go.
That will work so much better, thank you.
Does that make sense to everybody? So you guys are free to go unless you have questions.
Oh, found you, okay.
Oh, wait, Ekron J, it should be, sorry.
Uh,
J.
What is chapter
We'll
4?
just put stats. Let me,
Next time, maybe chapter 5. We can chapter 5, there might be Carly. Or chapter- There's Carly.
browse my
I'm just
computer.
dreading the
Recent.
web assigned things I have to do tomorrow.
And I'll be there next week, by the way. My car is just out of remission right now.
Okay, no problem. I'm gonna send it. I'm sending it in an email that just says stats.
Okay, that's fine.
And it's just a PDF and it's gonna say quick sheets on it because I did it on my tablet.
Yeah, that's fine.
I got it.
We'll work together. It's a quick book. Don't even sweat it.
Okay.
And also I think PDFs are cooler anyways because they're easier to read or to
Right.
like,
Do it, just do it.
Yeah.
and
open.
should- yeah.
It's just-
Okay,
it's just
so
something
where,
that
do you know where
actually
that's due?
Tonight.
Oh, I got it.
Yeah, that's
I don't
fine.
know where it's
And
due.
I'll
Oh,
take-
it's
I'll
probably
take the
in
highest score. Now, if you attempt
assigned.
the pre-test one
First
time.
call.
It's
eventually you'll get all the
in class
points, 'cause that's like
activities.
almost like attendance.
It's this one, isn't it?
Yeah,
And
9.
yeah.
Awesome.
Post-test is just
Because we
whatever you
were
get.
done with
But
like
both
the
the
first
pre-
half
all the
last
pre-test
week.
and post-test
Okay.
So,
Are limited amount, so.
Yeah, no, you're good. I still have to finish that one.
I'm
I'll probably
going-
finish it and hand it in tomorrow.
Okay, really quick, I have to, not that one. I'm gonna be here for a second. Because I have to take my
We'll get through chapter
my
4
thing
next
and
time,
save it.
and then within a week or two,
then-
we'll have the exam, but also.
still-
Review, present of your understanding of the material, and present to each other, and then like, then I'll be down to it later or something like that. So maybe 2 out, so it's cool, it's coming up, but we're still in, we have September, October, November.
Did you get the
part of
email, by the
December,
way?
We're already like.
Yeah, I did. Thank
Were
you.
you able
Ariel.
to see it?
5-ish in the first month. which
I did. It looks good.
we wanna be
Okay,
about
my
chapter
handwriting is
artist.
bad, but I
six,
figured
October,
it
so
was
we're
easier to
still
do it
trying
that way.
find-
I've never
No,
used
yeah,
that
no,
setting
they're good.
before on here, so I was
No,
like, I
it's-
hope it
it's gonna be
works.
1 through 4,
No, it did. Thank you guys so much.
Yeah, no problem.
Yeah.
9 through
Have a
12,
good
and it's
night.
not
Hopefully your
too
car
limited,
is
just-
You too, Marina. I know.
It's just
working.
relaxed exam.
I think they're super backed up right now with like auto shops, which is
Mhm.
really odd. 'Cause
Weird.
it seems like there's every car in the world on the road lately, so I don't understand what's going on.
That's so strange.
I know.
well. What's?
All right, have a good
All
night.
right.
All right, guys, you too.
Thank you.
I've recorded the whole time, so when I post this. you'll
Lovely.
have all-
Everyone that sees is gonna see. At least they can work through it with
Yeah.
us, kind of.
Yeah,
If you want to stop recording, otherwise you can keep.
yeah, I can stop recording if you want to talk to me.